co-host.
Present the technical achievements with a different perspective. So we had the idea of taking the example of a super use case, and taking you through the use case illustrates the achievements of the project. And this super use case is about the next pandemic, or the future pandemic. And the question is, are we ready, and how to prepare for the next pandemic? So the agenda of the session is here. So I will first start with a few scientific and data considerations, and then Philip will introduce how EOSC-Pillar has been addressing the data aggregation and data integration problems. Then we will move with Leonardo to the issue of solving the service findability and analytics problems related to this use case. And Gilles then will introduce a use case, a biomedical use case that was deployed within EOSC-Pillar, and through this concrete case shows a number of gaps and number of solutions that were found, but also a number of gaps that were identified. And then we will finish by a time for questions and discussions. Please keep your questions for the end of the session, precisely for this time of exchanges. So, are we ready for another pandemic? It's the title of a book by Bill Gates. I don't know if you had the opportunity to see it or to read it. Very interesting. So Bill Gates, I don't know if you had also the opportunity to see his TED conference about the topic. It was before COVID-19. Did you get a chance? You type on Google TED and TED Bill Gates and look at what he said a few years ago. It's pretty puzzling, amazing. But we come out of COVID-19 now, and if you look at literature, scientific journals, media, you see that the potential for new pandemics is considered very high among experts. So they identify many possible origins. So it could be zoonosis, like probably COVID, but the first candidate is bird flu. You know, there is right now in Europe a lot of birds and in France ducks are being killed because of this, because there is a large propagation of bird flu among chicken as well. And so wild and domestic birds are now carrying the virus, exchanging it. So there is a significant risk of human, bird to human, and then human to human transmission if the virus evolves. Then there are some epidemics, Ebola epidemics, which are of concern to WHO. There is also the question of the old viruses that are released by climate change because they are in the permafrost. And so there is an open question. Are there viruses that have disappeared that could reappear? And man-made viruses, biosecurity issues. So many, many questions. And the question now, what can we learn from COVID-19 outbreak to better prepare for future pandemics? And these key questions are the ones that I extracted from Bill Gates' book. And you see here, these are figures in blue and red of the number of the toll of COVID-19. So the official count is about 6 million. The estimated count is about 18 million. It's much less than the Spanish flu in the 20th century, but it's very significant. And the questions and the key questions are, how can we detect the disease earlier? So to make sure that one can take the proper actions early enough to limit the propagation. Second question, how to help people to be protected from the beginning. In France, we all know that there were no masks. The masks, the PCR tests were not available, so to take the proper protective actions from the beginning. How to find quickly new treatments, either using existing drugs or new drugs. How to be ready to produce vaccines. So these questions, they are not all addressed to the scientific community, but the scientific community has a major role to play in order to answer these questions better than we did than for COVID. But addressing these questions is a complex problem because it requires aggregating data from multiple data sources. It's a very multidisciplinary challenge to handle all these questions, each of them. And I've put here a number of data sources that are needed to address them. So first of all, of course, epidemiological data sources are absolutely needed. That includes hospital data with symptoms, the people that have been diagnosed with a new disease, what are the symptoms, but it includes also the number of positive tests. I mean, all what we know has been circulating or created for COVID. Then I move to biomolecular data sources. So what do they contain? They contain information about the virus, about its genome. But we know that the virus is not one virus. There are many, many strains, and it keeps changing. So the target is constantly changing. That's one of the challenges. And so these biomolecular data sources are absolutely necessary to monitor the evolution of the virus over the pandemic. Then we need also biostructural data sources. What are they needed for? They are needed for looking for new drugs, because that's where you are going to, that's the information you're going to use to find potentially new compounds or to test whether existing drugs are already potentially active. Sociological data sources, what are they needed for? For instance, if people are traveling, information about travels are very important because they tell you how the virus could circulate, propagate, or how it did circulate. Information about the adoption of for instance, carrying the mask. Are people really carrying the mask? So if people, there could be, I mean, I take the example of France, the adoption of wearing the mask have increased very much during the pandemic. At the beginning, people were reluctant, but then people realized it was important. So these sociological information are very important. So social network data sources are needed to access to this information. For instance, it has been shown that people were, there was an early warning about the pandemic through the consultation of some sites related to the symptoms. So people were looking for information about, for instance, losing the perception of smell. Losing smell, people are looking for information on Google. And so social media have, there are some strategies related to early warning. So all these databases, data sources are needed, but there are challenges. We need to aggregate the data coming from all these sources, but it has to be understood that you need to aggregate them at different scales. At the beginning of the pandemic, it's not an international it starts in one place. And COVID-19 started in Wuhan. So you need to access information about Wuhan data at the beginning. Of course, now we have international databases, information coming from everywhere. But the issue is not now. The issue is in February 2020. What were the key informations? What were the key data sets? And it was not national resources. It was not international resources. WHO had not a COVID-19 wonderful place where you find all the information. Nature didn't have a wonderful place where you had all the preprints. No, you have, all that was work in progress. And if we want to be able to respond quickly, we must be able to respond from the beginning. So we must be able to integrate regional data sets, regional data sources that are heterogeneous. I mean, every hospital is going to expose data differently in France, in China, in the States. So that's a challenge. We need to continuously monitor the scientific literature. You see the statistics, almost 87,000 articles published between January and October 2020. Why do you need to access to this literature? Because the truth of today is not the truth of tomorrow. I mean, I've been working on the first cluster in the east of France, and we were daily looking for the information about the virus, just about its contagiosity, about its morbidity. Things were changing. Remember, at the beginning, we were wondering if it was transmitted by hands. It took time to know if that it was a respiratory virus transmitted by just respiratory virus. So we need to continuously monitor the scientific literature, continuously monitor the emergence of new data sources. Again, whenever there is a new cluster, there is a new source of information. Can it be neglected? No, it's hugely important to have a big picture. And this big picture requires to have a granularity at a regional level. And the additional challenges is that you need a joint analysis of data coming from all these data sources for analysis workflows. For instance, epidemic modeling requires access to scientific literature. As I told you, you need the parameters of the virus. You need also epidemiological data sets. You need sociological data sets. As an example, if you put together a model of the pandemic, the propagation of the virus in France, if you do not include between March 15 and April 30 that there is a confinement, I mean, your model is just empty. You need this information about what has been the non-pharmaceutical interventions. So it's not just about epidemiology, it's epidemiology, sociology, and that's a challenge. And as I said already, data reprocessing, the truth of today is not the truth of tomorrow, especially in the early days. And even months after the beginning of the pandemic, there were still uncertainties of the rate of asymptomatic. I mean, this number has been fluctuating, and it would be very interesting to show the error bars and the evolution of this information. So you are on a constantly evolving ground, especially at the beginning. So you need to have an access, the capacity to discover data sets, to discover data sources, to aggregate them, and to enrich them semantically. Why? Because you have this heterogeneity. And this heterogeneity, being able to handle the heterogeneity of all these data sets is key to a rapid answer, a rapid response. So data aggregation, semantic enrichment, then data integration, and integrating the data into the different workflows that are required. Can you run these workflows once? No, you need to work to run them daily. You need to run them constantly because you have these new streams emerging, because you have all these truths that is constantly changing. And as a result, you can expect to produce epidemic models, you can monitor variants, you can look for new drugs, and you can advise governments about public health policies. So that's the introduction, that's the issues, that's what this use case involves. And now I'm going to give the floor to Philip, who is going to address this issue of the data and metadata aggregation. Philip? Yeah. So thank you, and I leave the floor now.
So, thank you, Vincent, for preparing the floor for what I want to talk about today. So it's about solving data and metadata aggregation and metadata integration problems. First, I would like to start with a bird's eye perspective. So do I have a pointer here? Okay, great. So this slide here on the right is an introductory slide from the Turing Award winner. So Turing Award, something like Nobel Prize for Computer Science from Jim Gray, from the last presentation that he gave in 2007. So it's 15 years old, but I think it's still valid today. And funnily, at this time, he was also working at Microsoft in the Microsoft Research eScience team. So this presentation also inspired a collection of articles about data-intensive science, also a very interesting book that I've linked here for you. And Jim Gray identified 4 paradigms in science. So the first paradigm he identified, and that has been valid for a long time, is the empirical paradigm. And as an example, he takes here Johannes Hevelius, astronomy scholar who created the maps of the moon in the 7th century. And at this time, the collection, processing, interpretation, information was all in one hand. Then, since the Renaissance, roughly, the theoretical paradigm prevailed. So in his presentation, Gray alludes to the so-called Friedmann equations here, which are from the 1920s, and they describe the expansion of space considering Einstein's general theory of relativity. So it's all astronomy based. And yeah, based on this analytical models and increasing computational power, the computational paradigm became prevalent with the evolution of computer power. And this allowed for the simulation of complex phenomena. And I think this paradigm is also still valid in many disciplines today. With the capability to crunch large amounts of data, we entered the data exploration paradigm. Some disciplines who have large amounts of data and that are well structured, they already entered this today, as we see here this example for an astronomic instrument. So they have a large amount of data coming in. Also here, the Fermi-Lab accelerator facility, they are collecting large amounts of data, and this data, they do discoveries. So these discoveries are, of course, processed by software. All information and knowledge is stored in computer, and there is somebody here, the scientists, interacting with this data by analyzing databases, using data management systems, statistics, etc. Other disciplines with smaller amount of data, they are still working, I would say, on organizing their data that they can apply these data-driven discovery methods and tools that are using here to organize their data, for example, ontologies. So after this short introduction, what are we doing here? Maybe a question, why are we doing it? We have basically, so we can classify three types of scientific projects. So we have the giga projects. They can afford creating their own IT infrastructure. They may share parts of it, like CERN is supporting Zenodo. We have mega projects, and also here the giga and mega. I mean, this can be translated into the volume in Europe, in euros. Okay, to speed up a bit. Yeah, we have this mega project, and they can contribute towards collective scientific IT infrastructures with some building blocks. And then the vast majority of research projects, they are small and depend on collective scientific IT infrastructure. And to show you a bit the shares, I put up here the number for the German Scientific Foundation, DFG. And yeah, this long tail that Christian Cucinello mentioned yesterday here is really taking, in terms of number of projects, the largest share. So let's get back to this question raised by Vincent. Are we ready? So we saw that many disciplines are contributing to the pool of relevant information. Their data and information flows to specialized data sinks. So these are repositories, databases, catalogs, websites. And these are typically domain-specific, managed by communities, and contain data about experiments, measurements, observations, simulation, models. These are then assessed and exploited, as we have seen in Jim Gray's slide, by this interaction through computers from these scientific groups. And from the FAIR principle, we know that the discoverability and actionability of data is a key component in the FAIR system. And in the slide I'm showing here, this exploitation is still kind of traditional. Yeah? If multiple sources are exploited, the load is put on these persons here for the retrieval, and yeah, they have to interact with many different data sources. So catalogs will contribute to the fairness and the exploitation. Here we have catalogs, but I think we can improve this by putting something in between here, which is a federated fair data space, which provides a tool both for these data producers here and these data consumers, contributing to enhance the overall fairness of these data sets, which are natively dispersed. So this federated fair data space is achieved by realizing services for dataset homogenization, enrichment, onboarding, and also if I look from this side here, services for the seamless discovery and access to this metadata, and also possibly data. Such a F2DS, so Federated Fair Data Space, we call it F2DS. It would typically be set up for a community, a project, or other structure requiring this homogeneous access here. And with the next slide, I would look a bit more what are the components, what this looks like. So this is a schematic of the F2DS toolset that was launched in the second release this September. And yeah, as I said, it takes into account several perspectives, the data provider side here and the data consumer side, and also the general interest of verificating data and promoting open science. So the system splits the task of the metadata retrieval and raw data exploration and ingestion to the two partners here. It provides these services using an integration into common AAI, so authentication and authorization infrastructure. And of course, not all components of this system need to be used in all cases or scenarios. So the training catalogs that Paula presented yesterday, for instance, it doesn't require the semantic enrichment service, at least yet, I would say. So let's take the perspective of the data provider for a moment. The data coming from these repositories are aligned using the DCAT model. So DCAT stands for Data Catalog Vocabulary. So it's a data schema, or it's even an ontology, but let's name it a schema here that specializes for cataloging data. And the catalog owners, they technically publish their metadata to an instance of the fair data point who sits in the center here. This fair data point, yes. This fair data point contributes to the verification of the data. So this verification is such that even without any change to the source data, the fairness level of the data can improve through the DCAT alignment when it enters this catalog. Then we have this semantic enrichment service, which can operate in two modes. Basically, it can either deduce from keywords which semantic concepts are represented in the data, or it alternatively has a GUI that will allow the data provider to manually enrich it using semantic concepts. So maybe to sum up this slide, the key benefits for the data provider that they can simply by registering the repository, their data can become more fair without any change to source data. And we can really effortlessly create multidisciplinary catalogs from internal or external resources. 3 minutes left. Periodic harvesting is supported so that the data sets are kept up to date. Something that Vincent mentioned in this talk that is really important in the especially early stages. Let's look at the data consumer perspective. So from there, their need is to have a seamless discovery and access to metadata and also the payload data. And for this F2DS is integrating what should I say, user-friendly catalog service built on a CCAN system. So CCAN stands for Comprehensive Knowledge Archive Network. And there is internal harvesting mechanisms. We will go into this in other presentations. And it presents then the available data to the consumer in a friendly manner and allows, for instance, fairness checking through the Fuji tool. And also this data catalog service is tightly integrated with virtual research environment, allowing then for a seamless downstream exploitation of the metadata and also payload data in this VIEs. Also with the possibility to crunch and yeah, to present using, for instance, RStudio, Jupyter Notebooks, etc. Leonardo will tell us more about this. So of course it saves working time and makes life easier. So the key benefits here are this seamless integration with the data processing, I would say. A single API that these people have to interact with from their notebooks, Galaxies, HPCs, Pangeos, or whatever processes the data. And they can also immediately assess the fairness level of the data they see here. So that's also additional help. So I come to the outlook one for the project. So we strive to improve the S2DS with the feedback from our community and testers as long as the project goes. We will provide a finalized version with registered repositories from different communities. So, and we will, at the end of the project, have integrated this previously unconnected service with the proof of concept for the search engine of the semantic concepts. And a bit on a broader level, what remains is certainly that domain-specific metadata should receive more attention. For instance, we know that the DCAT, I call it data schema now, DCAT data schema is extending for certain disciplines, like with GeoDCAT, to include geospatial metadata. We have shown here in this project that this semantic enrichment foundation with using this semantic enrichment service here is available, but I think now we can really build tools that exploit this enrichment based on the knowledge that is stored in ontologies. And also the payload data is often not readily actionable. This is a very big topic, but I think here the key is to promote the FAIR principles and generic tools to act with this. And also I would like to invite you to get deep dive into the technical details, and these will then be presented, including a demo in the session S7 today at 2 o'clock. With this, I thank you for your attention.
Thank you. Then we'll give the floor to Leonardo remotely.
So, good morning, everybody. I'm Leonardo Candela from the National Research Council of Italy. I'm really sorry for not being there with you, but some, personal issues are preventing me from traveling abroad. So, what I'm going to present now is the solution that have been proposed, some of the solutions that have been proposed by Pillar in order to address two challenges. So on one side, to find what services are available out of there and might be used in order to perform some scientific tasks, and also what are the facilities that might be put in place in order to facilitate the crunching of data after they have been aggregated and made available and fair. In the reality, let's say we should take the point of view of the researcher, of the scientist, and scientists at the end of the story need to be provided with working environment that provide them with everything they need in order to do their scientific investigation. So this working environment need to provide scientists with the data they need, they are willing to use for the specific investigation, the computing capacity that is needed in order to perform some tasks, and we know that some tasks are computing intensive, and also scientists need to be provided with the services that can be used in order to do certain analysis or to do certain data visualization, and so on and so forth. This working environment, let's say, should not be conceived to serve the needs of single scientists acting in isolation, but rather they should be oriented to serve the needs of what is usually called the community of practice. So a community of practice is a community of scientists that might come from diverse institutions, might come from diverse domains, so the multidisciplinary is there, and that are aggregated, let's say, around a specific scientific question or scientific challenge. So this way, the working environment becomes a facilitator of collaboration among these members, because they use or they make use of the same working environment. And it is very important that this expected working environment facilitate the co-creation and open science. With co-creation, we mean that, okay, the working environment is created and made available with some basic services, with some basic resources, but then thanks to the exploitation of the working environment from the community of practice, the environment grows and becomes, let's say, more close to the needs of the specific community of practice, because the community starts sharing some data, some early result, some pipeline that have been implemented. And by doing that, the environment becomes, let's say, tailored to serve the needs of the community. And of course, open science is there. And open science means that everything should be shared as early as possible or as early as convenient. We have seen also that the velocity characteristic is very important in this setting. Vincent stressed it a lot. So in essence, the needs of every community of practice change and change very often. New data might become available, new facility might become available. So the working environment should be developed thus to evolve according to the evolving needs of the community he is serving, the environment is serving. And also, you see, there is another characteristic, the multi-tenancy, meaning that every working environment should serve scientists that not necessarily are based in the same research institution, not necessarily are based in the same laboratory, but very often, because these environments are going to serve multidisciplinary cases, the user come from diverse institutions, from diverse country, and so on and so forth. So all these characteristics, let's say, make no longer viable the standard or traditional development approaches for working environment. So we cannot expect that before starting a community to use the working environment, we need to collect the requirement, we need to implement the technology, we need to test the technology, and only at this point the community can start using the environment, because this requires time, this requires resources that are not, let's say, working in these settings. So again, here there is the long tail of science that is very important here. So these environments are very important for the long tail of science. So the delivery model of this working environment should be the as a service one, because the scientists, because the community should not bother with the technicalities, but because they distract effort from their task, that is the scientific investigation. The last point that is very important to set the scene is open science. Open science, as we said, calls for sharing everything as everything that is a result or even a middle product of a scientific investigation. We cannot expect that everything is shared only at the very end when a paper with the summary result is going to be produced, but things are expected to be shared continuously. And in doing that, the working environment should take into account the point of view of both the side of the story. I mean, the provider of the things and the consumer of the things that is going to be shared. So in order to, let's say, satisfy the needs that I tried to describe in the previous slide, EOSC-Pillar put in place three major, let's say, three major area of facility. So on one side, we focus on developing an approach supporting the building and the development of national or thematic service catalog, thus to support the discovery of what exists out of there in terms of services. The second family of approaches is about the development, again, of a catalog-driven solution, facilitating not only the sharing, but also the publishing of data and any other product that might result from a scientific investigation. And the last but not least is an array of services supporting the creation of virtual research environment, as well as other services that might be of interest for a community that is willing to make use of them. So let's now analyze one by one. Okay, for what regards national or thematic service catalog, one can say, okay, why do we need another catalog? We know that EOSC is building its own catalog of services. We know that community or let's say some country are developing their own catalog of services, and not only of services. But we should take into account that every catalog is designed with a designated community in mind. And because of this, you know, we cannot expect that it match the needs of other community, okay? And of course, you know, when someone thinks to start developing a new catalog, he or she should do not start from scratch, because of this plenty of experience in developing catalog, and should prepare for interoperability, because this way the development of the catalog is let's say easiest, and also contribute to others that are willing to develop a catalog. So the model that we end up and that we propose for this typology of service is depicted in this picture. So as you see, the service is at the center, and every service registry represents, let's say, a service on its own. So because of this, there is a community that is responsible for the management of the specific service. And at the level of the single service, the community decides how services are going to be described, what are the functionality in terms of discovery and access that the catalog should offer, and what is the management policy and procedure that govern the development of the catalog. So the catalog is a real product of its own target community. But as I said, we should not start from scratch in doing that. So the catalog, for what regards the provisioning side of the story, should offer both functionality for explicitly pushing new service description into it, and this can be done by graphical user interface as well as by API for programmatic publishing, but also it should be equipped, and let me say, this is this part of the model that I described so far, in essence, was the model underlying also the development of the EOSC catalog. Okay, but now even the EOSC catalog is changing the way it is expected to be populated by introducing the harvesting side of the story. So in essence, a catalog can also be populated by systematically collecting services from existing catalogs. So you see, there is the harvesting side of the story here. And let's say, once you manage to develop a service registry and to populate it, it is very important to offer the content of the specific catalog in two ways. So certainly by using a graphical user interface where human user can go and can search and browse for the available services, but also the content should be exposed by interfaces, web-based interfaces, including standard, that make it possible for other entity or institution or community that are willing to develop their own catalog to do that by even making use of the content of the specific catalog developed here. You see that there are also a couple of handshake. With handshake here, the idea is to stress the idea is to stress that apart from these technological parts, okay, there are some agreement that need to be established in order to make it possible to harvest from other repository or to make its own content to be harvested by other. And very often, let's say, this agreement side of the story is the most challenging one with respect to the technical one. So
Leonardo,
we implement.
Leonardo, you have 8 minutes left.
Yeah, I know. I have the timer with me. Anyhow, so we instantiated this model and created the Italian catalog of services. It is available at the URL that you can see there. In order to facilitate the interoperability with EOSC and to not start from scratch, as I said, we decided that we can count on EOSC provider and EOSC resource profile in order to describe the services and the provider into this catalog. We will see later on that it is not just a catalog service in isolation, but in the reality, it is embedded and made available by a virtual research environment that the people can use in order to develop the catalog. So, for instance, to comment on what's in, to propose new item to be added, and so on and so forth. Okay, but this catalog at the end of the story is a proof of concept, and it has been populated with a number of selected services from some Italian research performing organization. The work is not complete and is not going to end with Pillar. Because we are now liaising with the Italian CDI community that is interested in somehow uptaking the catalog and developing it to collect the entire, let's say, list of services available in Italy. We will certainly test, when it becomes available, the onboard of this catalog into the EOSC one. And we plan to produce, let's say, a white paper where we describe our experience and the overall solution before the end of Pillar. The second family of approaches that we developed is, again, a catalog-driven stuff. In this case, it's not for services, but it is the side of the story that was touched by Philippe in its own part as one of the components of F2DS toolset. So this catalog make it possible to search and browse its content in a very user-friendly way. The item of the catalog are made available by a number of ways, including the web-based, the REST API, or even DCAT. And this catalog make it possible to publish, in essence, every typology of research outcome. In order to do that, we extended the data model of DCAT, of CCAN, that is the enabling technology, by giving the possibility to have catalog item that, apart being characterized by some common metadata, are also characterized by a type. And the type, in essence, is a sort of application profile that can be defined by every community that instantiated the catalog in order to define additional metadata attributes that are worth being captured for the specific typology of item. And then here it is also important to stress that every catalog item is in the reality pointing to as many resources are needed. So you see that it is easy to create entry into the catalog that in the reality are pointing to any number of data sets that are worth being considered as part of a unit of information. And you see some example here. And as Philip said, more information will be given in the afternoon. So the third part of services that we have seen, that we have put in place, is related with virtual research environment. So you see here what the virtual research environment is. So in essence, they are working environment tailored to serve the needs of their own designated community. And the important aspect to be stressed here is that every working environment is made available as a service and offer a number of opportunity or option for involving the community into the creation and the development of the working environment itself. So you know the motto, build it that they will come. This doesn't work simply. So the community should contribute to the development of the environment in order to make it close to their own needs. And this might happen because the community, for instance, share object in this working environment. So this object became available for all the members of the specific virtual research environment. The community can share the implementation of analytics pipeline. And again, this becomes available for all the members of the working environment. And also the community, let's say, can decide to integrate into the working environment specific application or specific services. So this service in the context of EOS-Pillar have been used in order to create 12 virtual research environments. They are very diverse each other. So some of them are related with the use cases that we will see later on. Some of them have been created for supporting courses. One of them was supporting the development of the training material that you have seen yesterday, and so on and so forth. So overall, these working environment, let's say, are not really production ready, especially from the community point of view. They can be considered as a sort of proof of concept of making use of this environment to do some tasks. And we managed to serve 500 users. So 500 users are somehow consuming this 12 virtual research environment. And since the beginning of the project, through this working environment, more than 14,000 working sections have been initiated. Apart from these services for creating virtual research environment, EOS-Pillar mobilized a very wide array of services that can be used. Certainly, I will not enter now into the detail. There is a session dedicated to this in the afternoon. This is my last slide, where I would like to showcase how a virtual research environment for supporting a COVID use case related looks like. So this is an environment for drug discovery. As you can see, it offers a number of functionality for analytics, the catalog for facilitating the publishing, the social networking for communicating among the members. And for what regards the analytics, here it is important to stress the fact that this working environment offers a rich array of solutions that are either hosted in the same infrastructure like Jupyter and RStudio, but also made available by third-party provider. And this is the case for the VIP platform, that is a service made available by an institution in France. And all of them are integrated into the same working environment and can be used in a seamless way by the community. And you see here in the corner one of the workflow that the community is interested in, let's say, implementing by the virtual research environment. And I can say that this workflow have been implemented in complete, without the intervention of the VRE provider, by the one CNR institute. And now it is part of the computing facility that are available for everybody. So in essence, this concludes my very brief presentation about the offering of the EOS-Pillar for what regards service discovery and analytics. And I think that I can now pass the floor to Gilles that is going to present the point of view, let's say, of someone that is willing to implement a real use case.
Thank you very much, Leonardo. So Gilles is now taking the floor.
Okay, please remember to speak through your mic. Sure.
Okay, so hello everyone. I know we are late and I'm the last man standing between you and coffee, so I'll try to be brief and as interesting as possible and to allow some time for the discussion after my talk. So we've seen a lot of interesting point of views in this session on the different tools that can be built and put together. Now, the idea was here to see how does this actually match and what can we really do with it. And Vincent asked me to do this presentation on the use case that we implemented within EOSC-Pillar, which is the use case 6 in the project. You'll know a bit more about it in the next session, led by Alessandro. It's one of the 9 use cases of the project. Title, Exploring Reference Data Through Existing Computing Services of the Bioinformatics Community. That's unreasonably long and a name, but I mean, the idea was actually to investigate how we could link the data, the tools, and the analysis for a specific case in using bioinformatics data. So this is a use case that wanted to work with tools, existing tools in the community. The tools we choose was Galaxy, which is a known and very widely used tool in bioinformatics, with the aim in mind to actually make its use more simple for user by connecting it, allowing it to connect to source data more seamlessly. And of course, since we're talking about bioinformatics, the idea behind was to make sure that wherever there are health data restrictions, that it's taken into account. I won't spend much time on this. This is more for reference for later. These are the links that will tell you more about the use case. You have a poster outside. There will be a session afterwards. Please come and ask if you have more questions about the use case background. Now, what is it we wanted to do? We defined theoretical scenarios of what we wanted to achieve. We have many different ways of deploying and using Galaxy. Users have their ways, there are public instances we can deploy locally. And the idea was that we would build theoretical scenarios around it, like using some kind of reference data from different repositories in a public Galaxy, I mean, publicly available Galaxy instance, then do the same thing through a locally deployed Galaxy, if for whatever reasons we don't want to actually access the data from a central instance. Then do the same, but with data on which we assume there are some restrictions. So we need to make sure that Galaxy can run in a secured infrastructure, which has specific requirements. And then the fourth scenario is kind of a meta scenario that wants to compare all those results, run different configurations, and make sure that the results are the same. It's for the reproducibility aspect. That, of course, highlighted some challenges. The first one being to make sure that the different deployments have coherency and that the reproducibility is ensured. Now, from a tool perspective, we needed to make sure that Galaxy, whichever flavor we wanted to deploy, it was possible to deploy it in a secured environment with some restrictions. So no communication with the outside, well, the specific restriction of secured environment, and that the results would be similar to its public counterpart. Of course, if we want this to be working, we needed to have it integrated in a global authentication system to make sure there are no problems and make the service available, which in itself is a challenge. Now, this was what we wanted to do, and what did we actually do? We actually, in the use case, implemented better rules for Galaxy deployment, thanks to our colleagues from INFN, from EBM, and from IFB. which led to providing easily deployable Galaxy instances close to the data, Galaxy on-demand service that we could deploy. It was similar to its public counterpart. We managed to populate reference data into the federated data space and to actually enrich it. So this is something that you will see in the demo later on today that Marwa will be presenting. Galaxy was successfully deployed in a secured environment. And we had a working demonstrator with a light workflow. Like we managed to use some data populated through the F2DS to run a workflow on it and have a result. And there's been a tremendous amount of work on the analysis on transnational health data restrictions. This echoes to what Nadina was presenting yesterday. I mean, one of the work that's been done on this. And we've worked with a real-life user community, which is the HCNV community, Human Copy Number Variation, so specific field in bioinformatics, where we reached out to this community to figure out what the real use case could be and how they could use what we did in a real-life science and not just demonstrator. Just to put that in perspective as to how did we use the whole EOSC-Pillar framework for that. So there were links on the legal aspect, and again, this is what Nadina presented yesterday, and linked with Work Package 4 on the health data, use of health data for scientific purposes. Linked with, of course, the Work Package 5 and the F2DS development on publishing, enriching metadata in the federated data space. Strong link with the Work Package 7 and services, because we were heavily relying on Laniakea service, which is provided as part of the services in Work Package 7, developed by colleagues from INFN and EBIOM. And of course, communication, dissemination, we tried to reach out to as many people as possible as part of Work Package 2. So now, being entirely honest with you as what did work and what didn't. So starting on the good side, there's a lot of things that worked well, including the international collaboration, the data publication, the enrichment, Galaxy, the use of the central instance, the deployment of the local Galaxy, the deployment of secured infrastructure. There's a lot of things that work well, and this is good. Now, there are a few things that didn't work so well. This is not criticism, it's just a way to improve things. We didn't manage to run workflow in huge files because of, well, memory problems. I mean, it's a technical limitation. We didn't manage in the end to connect, to plug two of the bits in our final workflow, like connecting the federated data space to the final consumer, to the central Galaxy instance. And we didn't manage to go until the end in using the F2DS to fetch data from Galaxy. So these are things that we wanted to do and we didn't manage to achieve during the time frame of the project. Now, coming back to Vincent's presentation on, are we ready to a new pandemic? How what we did in this use case translates to such a big question. We did some technical work that can be reused, like publishing the data to a federated data space, making it available, consuming it through a tool. There are some technical aspects that we did during the project work on, and that are a step forward in getting into the direction of, can we, for example, cross data from biomolecular sources and virus sequencing analysis and just merge them in a scientific workflow. Tools, I mean, some of what Vincent presented can be done in Galaxy because there are some tools that can be used in Galaxy, and if we have the workflow that allows for it, it's a step again. And define this global workflow, that how could these different tools communicate? How can we work in a secured environment, especially when we are talking about patient data, which is, in the case of a pandemic, is very important. And last but not least, the community awareness, like reaching out to the community, saying that we might be able to help you with tools is something that again, adds some brick to the overall layer. Now, I know this is a technical track and most of it is technical, yet there are some wider considerations that I can't help but sharing with you. And this comes from a real experience when we wanted to say, okay, how could we help with COVID when COVID arose 2 years ago? The answer we got was, okay, not now, we have other things to think about. And this is exactly that. Like, if you want to propose solutions, don't do this in the middle of a crisis because you won't get people ready to listen to you. So yeah, this is really from our experience what happens. But then when the crisis is over, people don't think about improving things anymore. Like, I mean, you just, okay, when the crisis occurs, it's too late, but when the crisis is over, you just say, okay, the crisis is over. And you don't think about the next crisis. So if you don't plan about changing your shoes between 2 marathons, it's likely that the next time you run, it will still hurt. So now, the thing we have to bear in mind here is that, yeah, I mean, the comparison has its limits. The pandemic is not a marathon. You don't know when it will occur. But from what Vincent said, what I take is that it's not the question of if it will occur or not, it's when will it occur. So we'd better be prepared when it comes. I'm not being alarmist here, it's just like consideration. It will happen at some point. So let's be prepared and let's not just think, okay, we'll think about it later. Now, coming back to the technical aspect, because the idea was just to see, okay, how could we solve this at our level? I'm coming back to the what didn't work bits that I presented earlier. Running workflow in huge files, connecting tools, using methods. As a kind of, we have technical resources issue, we have technological issues, we have functionality issues. The good news is that none of it is unsolvable. It's a question of time and effort. And the time frame of a project is limited, so we could not go until the end, but it's not because it's impossible. Now, the way we could solve this is, of course, to work on the scalability aspect of tools and to go further than just the prototype step. So if we want to actually do something, we need to put the resources in it to make it work. We need to, of course, improve the reuse and sharing practices based especially on thinking interoperability, because one of the key things is that interoperability should be thought by design, and that we saw it in the previous presentation by Philip and by Leonardo. It's really important if we build tools that we think that these tools will be used in contexts that we don't know about, and we need to make sure that they are usable in any context and that they are as interoperable as possible. The last bit is probably the most important, that we need to think long-term. This long-term thinking is just to bear in mind that when we are in a project that has a limited time frame, our line of thought should not be limited to the time frame of this project, but to what we want to achieve in the longer term. And it's also a question thinking about the return of investment that institution, people, teams can make in a project. If you look at this return on investment in the short term, it's probably, I mean, any project has a very small return on investment. Like if between your 2 marathons you change your shoes, just after buying your shoes, what's the return on investment? Nothing. You just spend money. But if you look 3 years later, you would say, okay, those new shoes, I've used them in 3 marathons and my feet don't hurt anymore. So the return on investment in the long term can be good. And if you just look in the short term, it's not. So that's something to bear in mind. Now, again, on the technical aspect, when looking at all presentation, technical, political, this is a bit how EOSC sometimes looks like. Okay, so it might feel like a bit complicated. And I'm coming back here to different talks that occurred yesterday, and the question about that was during the last session yesterday, where the question was, do you think that EOSC should not, users don't have to care about EOSC as long as it works? And the answer was sort of like agree, disagree. People were not, I mean, there were different points of view on this. And I think the idea is somewhere in between. So yes, if it works, people don't want to see something like that, but just want to see something like that. But in order for something like that to happen, people have to get involved. So the answer is in between. And then there are two messages behind this. So the one which is shown here, like we need to build something on bricks that are compatible, otherwise that will be difficult. But then we need to figure out who is building the bricks and who is doing something with the bricks. And this is my personal opinion that EOSC is here to provide the bricks, and the users are here to build something with the bricks, but they have to be provided with the bricks. Users don't want something on the shelf that they just use, because they have to use something that they have designed, but to design it properly, they have to use bricks that just fit with one another properly. So that's probably what's one of the best achievements in EOSC-Pillar, that there have been some bricks that have been built, and that allow the different user community to use those bricks to actually connect and do something that is meaningful for them. So that's my final slide. Some general consideration that there are technical issues, but they are not the most blocking. So we need to make sure that to solve those technical issues, we have the political support behind. We have, of course, to use projects to fulfill these long-term goals that I spoke about, and not the other way around. And just bear in mind that the EOSC is what we will make of it, and that we need to actually get involved to take the most of it, and get out of the comfort zone sometimes. So not just sticking to what we did in previous project, but go the further mile to actually improve things and make it something usable for the next use case that we don't know about, because when it will occur, it will be too late to take care about it. And that's it.
Okay, thank you very much. So the goal we had was to leave time for questions and discussions. And now we open the floor for your input into this session.
Oh, always works. I have a question for Vincent. It was an interesting talk. One thing that seemed to me, perhaps not explicitly mentioned, was the political aspect, which in principle can torpedo a lot of the effort in the open science. So are there efforts or mechanisms to try and address this?
You mean political efforts to build up a joint effort to prepare for the next pandemic? That's the question.
No, it's more the political, from the current pandemic, we've seen weaponization of the COVID virus. For example, during the disastrous Trump era, they were trying to stigmatize China with as the culprits of the virus. So and then China was reducing the amount of information that was available. So how to try and combat this in the next
yeah. The political dimension is hugely important in addressing or preparing for the next pandemic. Clearly, we've seen a lot of things in the last 2 years, but I think what is important is that we, on the scientific part, we get ready. And I think also that this open science policy that is being promoted worldwide is really going in the right direction. Now, it will never prevent some countries to hide information, and it will never prevent some scientists to hide information, because because for some personal career issues, what we need to do, I think, is to prepare as much as possible on our side, and the rest of what there are things that are beyond our ability, and we should not try to enter this game. It's not our point. The point is, for instance, what I like very much with Gilles' feedback is that if I want to connect F2DS to Galaxy, I have an AAI problem. I mean, it has to be solved. It has to be solved. I mean, it clearly it's a gap, but it's concrete, and we see concretely. I think what I learned mostly from EOS-Pillar is that making EOS concrete, and making EOS concrete, you have this kind of clear gaps. Let's address these gaps and make EOS an environment where these things can be done. And then we will have to convince political people to support it. I want to give a testimony from discussions with in a meeting, and I heard that there were many, for example, projects funded by the French ministry to address COVID, but every single project built its own database, and all these databases have been kept private. So that part, of course, we cannot. I mean, it has to be decided at political level. But the tools really were not ready to connect these databases, to make them available, to merge them for other scientists to use. Okay. Any other question, comment?
Hello. Yes, I think it's a really interesting take to try to show this combination of requirements and the tools that we developed here in Pillar and presented in this session. But just a second ago, there was this announcement for a RDA call for interoperability. So we're on the top of this. With these efforts, so we can continue if we apply for funding this for those people. But what want to ask is maybe Philip or Leonardo, when you worked on these tools that are then put into a workflow by Gilles, what was your start with Philip? What effort did you bring to make this product or this tool that you had applicable for Gilles, his workflow? Now, for one thing is that if you build, so on one hand, of course, these tools cannot be immensely flexible, so you have to be in part straightforward and how you implement these things, and the science that Gilles is throwing at you will change over the time, right? And if you now have the discussion, well, we have to be prepared for the future. Well, in the future, probably there is a different demand on what you require from these tools, and these things are not fixed. So there's always some friction in the incompatibility. But asking you, Philip, what work did you do to make these tools as flexible as possible, or what interaction was there with the user community, in this case, the ones that Gilles presented, to enable these tools for his workflow? And what happened to the other workflows that you had in mind, or what happened to the other users that you had in mind? Did you have to cut them off? Did you have to change things that all of a sudden other users couldn't use it anymore? Or how did that work? And maybe later Leonardo can say the same.
So I think Jos, what you're pointing to is that we have to here build tools that are generic in a certain manner, and I think the identifying what is generic and what is specific is a hard task and requires a lot of communication. I think during the project we had mechanisms set up for this communication, for identification of needs, for regular feedback loops. In terms of how this goes through the, let's say, design cascade into the implementation, I would have to forward this to our specialists, namely Olivier and Baptiste, who will be able to talk about this. What was not feasible, and how we deal with this, I think we were a bit later than we planned to be during the project, so it was unfortunately the use cases that could not easily or who were not served. So we didn't have a opportunity to do a second or third round with them in order to address their needs. Yeah, so maybe that's my main statement on this. And Leo, do you want to add to Jos' question here?
Yes, Jos, your question is very interesting, because allow me to stress one time more the fact that some of the services that for instance, the virtual research environment or the virtual research environment offer in the reality are framework that make it possible for the community of users to make use of them and to inject into the specific framework, the specific service, its own peculiarity. So you have seen in Gilles' slide with the bricks, this is exactly the idea. So in essence, the technology provider managed to arrive up to a certain point, but then there is the community, the final user, that should be posed in a position to inject into this technology its own solution. We cannot expect that the perfect tool exists. Every tool has some limitation, and some of these limitation doesn't depend from the tool per se, but depends on the specific exploitation of the tool that the community is planning to do. And we do have a number of examples of these needs. So for instance, you have seen that the catalog is generic with respect to the content that can be published. So the community can fine-tune the item that appear into the catalog and become searchable and accessible in a standard way. So the technology ends at a certain point, then there is the community that customizes the service to serve its own need. And the same is for analytics. So for analytics, you provide an environment that offers a computing capacity, but then the community should be posed in a position to implement into the analytic platform its own pipeline. And this is the case, for instance, for Galaxy, but this is the case for the other analytics pipeline. We cannot expect that the technology is implemented completely by the service provider, you know?
Yeah. So I don't want to take all the time, but it's an interesting take indeed, Leonardo. And I think in this case, Gilles, there could be a intermediate step between all these building blocks that you had on a pile, and then the fixed workflows. I mean, the user is all, according to Leonardo, and in certain respect also that mentioned by Philip, in charge of putting these building blocks in the right order and the right sequence, right?
That's exactly what I wanted to say. Thanks, Josh. So yeah, the in-between is, if you've seen latest boxes of Lego, you would say that there's a lot of blocks that look nothing like the little squares that you're used to. There's lots of different shapes and different stuff that allows you to build a lot of different things, but they're still compatible. So the intermediate step is for the user communities to come with a design and say, okay, I want this to be made Lego compatible. And then this is what the user community can bring. I mean, there's a lot of tools user community made that could be interfaced with services at the EOSC level. And for that to happen, the user communities have to be involved. So it's a continuum. It's not just the service provider, the technology provider, the users. And one of the reasons why in the use case I presented, we had good interaction with the technical aspect is that because we were also involved in the different work packages that did work on the technical aspect. So the work that Marwa will be presenting in the demo in the session this afternoon is like that. We've been working closely with, okay, we've got this kind of data, we want to populate them, we want to enrich them, let's do this. And it's a common work. So the interoperability is not just on the technical side, it's on the user side as well, on the people side. So we have to work together for things to happen.
Thank you. Thank you.
Thank you. My name is Max Dumoulin. I have a question maybe to all of you. I was just thinking, because of all these use cases, they're very interesting, of course, and it's very much in development. And I was just wondering if any of you have also thought about providing feedback loops to the providers of the data, because it's clearly very interesting for those people, and maybe also rewarding if they know how the data is used by whom and what the struggles were of the users with the data. So I was just wondering if you have any thoughts on providing feedback loops to the providers of the data, because I think that's one of the issues that also needs to be solved, making it more rewarding to have high quality data in an interoperable format available. So I'm not sure who would like to answer, but I was wondering if any of you had any thoughts on this. Thank you.
I can answer for the specific use case I presented. When we reached out to this human copy number variation community, the reference data are provided by the NIST, which is a national board, I think, in the US. And we got in touch with them saying, okay, we want to use this kind of data sets. How could we use this? How could we, and they actually helped figuring out which data set to use, what to provide. So there was a human feedback. So it did happen. Now the second data set we use for the demonstration purpose, the small one, the light one, is data sets from a Galaxy training, which comes from the Galaxy community, and we were in touch also with the data producer. So yes, the feedback is here from our side. But maybe your question was more generic. How can we ensure that the feedback is here to data producer? So yeah, well, automated feedback to data producer is something I don't know how to answer about that. How would you do that?
Well, I think this feedback will come in the future if we get forward with curation mechanisms. Then this curation will provide a feedback mechanism. But I personally don't see a clear picture how this will look like from a technical point of view today.
Thank
you. Actually, yeah, an idea maybe on that is that since there is some enrichment, metadata enrichment at the F2DS level, an idea could be to actually feed back this metadata enrichment to the data owner or to the data producer. So saying, okay, we've taken metadata from your data sets, we enrich them, and we can populate them back. And that would be a way to actually automate this kind of feedback.
Now, one thing you could do is at least establish that it has happened, that it has been used, right? That's a small start, right? So that could be something. But sure, the quality of the feedback is, I agree, it's more difficult, but maybe just establishing that it has happened and it has been used is a nice first step. But thank you for your answer.
Technically, if I take a concrete example from our side, we have data that we will be populating in the institutional repository. On the software level, this is Dataverse, and then I'm looking to my colleagues, which are more competent in this domain. But if I'm not mistaken, you get from Dataverse the ability to actually count the number of times the data sets have been accessed. And this is probably something that can be done even through when you get an access through an API to this data. So basically, there could be a technical possible mechanism just to count, okay, this data set has been accessed through the F2DS that many times, and that would probably help. I think I'm right with that, right? We can count the Okay. So yeah, that would be a way.
Thank you.
So I think it's 10:30, so we are going to close the session. Oh, Jan, you want the last question? Oh, you want to say something, Leonardo? Short? Okay.
No, it's okay. It's okay.
It's okay, sure. Okay, thank you. Thank you very much for your attention. So I think these use cases illustrates well both what has been achieved through EOSC-Pillar and also the gaps and the issues. And so I hope this session was of interest for you, for your reflections and for the future. Thank you very much.
Thank you, everyone. So see you back at 11 for the next session. In the meantime, please enjoy your coffee.
which are usually managed and preserved separately in domain-independent repositories. Anne wants to enlarge her user base, so she wants to make her service available in the European Open Science Cloud, an initiative by the European Commission which fosters sharing of services and data among the scientific community, as well as other open science practices. Through the EOSC portal, Anne learns that EOSC offers several core services, including federated authentication and authorization infrastructures, AI. Integrating her service with Federated AI will allow her service to reach international users from different scientific communities, enabling them to use their existing federated credentials. The Indigo Identity and Access Management IAM service, one of the EOSC Federated AI solutions, features a simple design, uses open standards such as OpenID Connect, is flexible to different use cases, and auditable. Anne gets in touch with Pietro, an expert on the Indigo IAM service. With the guidelines provided by the EOSC-Pillar project and Pietro's help, Anne is able to integrate a federated AI into her service with a few clicks. In Indigo IAM, at the operational level, different roles, such as admins and standard users with different access privileges can be defined. Now scientists from different communities and from all over the world can access Anne's service without registration. For example, Ursula, a scientist from the German research community and from another institution, can log into Anne's service. Moreover, scientists can seamlessly use different EOSC services at the same time with a single sign-on. For more information, visit EOSC-Pillar.eu.
On the technical side in the project, 2021 has seen the first release of the Federated Fair Data Space, which provides a framework for aggregating metadata from heterogeneous and distributed data repositories and aligning the metadata of these repositories with the DCAT model to publish them in the end into an instance of the Fair Data Point reference implementation that has been developed with one of our collaborating projects, the Fair is Fair project. The Fair Data Point constitutes a centralized and harmonized metadata catalog and contribute to the improvement of the verification of the different repositories within the project without requiring any change. This first version of the Federated Fair Data Space has been delivered in September 2021 and is currently being extensively tested by the different use cases in the project to enrich and transform their metadata content. After designing the index of ontological concepts, we are currently implementing a first version to integrate this index into our Federated Fair Data Space to allow the enrichment of metadata with ontological material. We are continuously improving the Federated Fair Data Space with the feedback from the different communities and testers. We also continue to work on aligning and providing services and infrastructure support for the community demonstrator within the projects. We worked on establishing guidelines for integrating some of these services into EOSC. we are aiming to provide a finalized version with registered data repositories from the different communities. We are also expecting to have integrated previously unconnected service into the EOSC ecosystem. We will provide a proof of concept of a multidisciplinary search engine to find concepts from semantic artifacts that is built upon relevant community resources. We will also release an Anthroportal instance that will store all the semantic artifacts from the communities in Pillar that were not easily accessible. We will provide a set of services that are integrated with Common AI, and we will provide an extended set of ready-to-use infrastructure services, such as the D4Science virtual research environment, dedicated and improved Galaxy workflow services, and more.
La féerisation des données, qui, si je me rappelle, signifie findable, accessible, interoperable et reusable. Ça a un impact tout à fait positif, ne serait-ce que pour créer des outils à destination de la recherche, mais aussi des outils pour les étudiants.
J'ai créé avec des collègues une base de données bilingue avec des textes en langue amérindienne de l'époque coloniale jusqu'au début de l'époque républicaine. On a réussi notre pari, à savoir de faire une base de données utilisable par des personnes qui ne sont pas dans le noyau qui a créé cette base.
C'est exactement le rôle de ce bibliothécaire du temps de ma thèse qui allait voir les chercheurs et qui lui disait « s'il vous plaît, ramenez les livres pour que tout le monde puisse les utiliser ». Donc le premier impact pour moi, c'est celui-là, c'est d'amener les collègues à partager.
Et j'ai commencé à mettre la version PDF sur HAL, ne serait-ce que pour le signalement, mais aussi pour la récupération des données elles-mêmes. Mais c'est vrai que pour les collègues dans le domaine de l'histoire littéraire, ce qui compte, c'est l'édition papier.
Nous sommes dans un lieu où parfois encore il y a une forme de personnalisation qui peut être assez aiguë de résultats que l'on a acquis et que l'on n'a pas envie de partager trop vite.
Ce qu'il faut comprendre, c'est que par le partage de données, quand c'est bien déposé, que les métadonnées sont bien enregistrées, etc., nous, en tant que créateurs de la donnée, on n'est pas effacés. Au contraire, notre présence, elle est affirmée.
Dire qu'on a travaillé sur des données qui sont inaccessibles, ça veut dire qu'on n'a pas travaillé. Vraiment, l'exigence chez nous de reproductibilité en maths et en stats et en informatique, elle prend des proportions très importantes.
Il y a ce paradoxe, il y a ce double tranchant, d'un côté d'une nécessité d'ouverture et puis d'autre côté, attention, vie privée.
Si on garde les données pour nous, en fait, il ne se passera pas grand-chose. Le fait de rendre tout de suite les textes accessibles, cela a encouragé nos collègues historiens de nous envoyer leurs textes, donc d'enrichir notre base. Nous, on leur traduisait et on le mettait en ligne. Du coup, c'était d'emblée partagé.
Tout le monde refait tout le temps le même travail parce que c'est pas fait de la même manière et surtout parce qu'on ne sait pas de quelle manière c'est fait.
Tout l'enjeu en fait pour les arts de la scène, c'est de définir ces champs de description pour ensuite pouvoir exploiter cette information sur le plan scientifique.
Comment on repense les corpus que l'on fait? Qu'est-ce que d'autres vont pouvoir faire avec mes données? Et donc, les préparer d'une certaine manière.
On a dû se mettre d'accord sur un certain nombre de données que nous voulions voir dans cette base de texte. Il a fallu aussi se mettre d'accord sur ce qu'on appelle les métadonnées, c'est-à-dire les éléments qui permettent de décrire les textes que nous mettons dans la base de données.
Plus on va donner d'éléments de contexte, plus on va donner des éléments pour comprendre comment ces données ont été construites, plus, à mon sens, elles vont être réappropriables.
Je ne me fais pas trop de soucis sur la pérennité des données. On réfléchit à ça. On a le PDF Archival qui est complètement stable. On a le PET format CSV qui est increvable.
Les SHS, c'est plus problématique parce que les données ont besoin de plus de contextualisation. Il y a des questions d'homogénéité dans le temps, dans l'espace, notamment lorsqu'on travaille sur des données dans ton nom.
On a une masse de textes. Je crois que si on réfléchit dans la perspective faire, on peut négocier à commencer par certains textes, à continuer avec d'autres. Et cela nous amènera plus rapidement, collectivement, à cet objectif d'une bibliothèque qui serait requêtable par tous, qui serait exploitable par tous.
Il y a d'autres aspects qui sont ceux du danger d'une forme de standardisation trop prononcée qui, justement, tendrait à ne recourir qu'à des métriques, qu'à des formes d'indexation strictement quantitatives ou strictement logiques, en négligeant l'ensemble de ce qui est qualitatif, qui est une part irréductible des données en sciences humaines en général et en archéologie en particulier.
S'il y a des règles, des standards sur les contenus, il n'y en a pas sur la façon dont on les traite ou comment on arrive à faire ce qu'on fait aux données. Donc il y a toute une partie de notre travail qui mérite d'être observée, décrite et formalisée.
C'est-à-dire quand on écrit, quand on collecte des données, d'avoir un protocole de recherche explicite, écrit et compréhensible.
Il y avait un devoir de trouver le moyen de pouvoir diffuser des connaissances très brutes, très liées au travail, pour en faire des synthèses. Ça me semble extrêmement important, que les données deviennent simplifiées, transformées, accessibles.
On va véritablement moins surreprésenter le travail de recherche comme une quête solitaire d'une vérité plus ou moins saisissable, pour beaucoup plus un travail collectif.
On a mobilisé les compétences d'historiens, de philologues, linguistes et d'anthropologues. Un projet de base de données de cette ampleur-là ne peut pas se faire sans une équipe pluridisciplinaire. Et c'est justement parce qu'elle est pluridisciplinaire que la donnée est la plus partagée d'une certaine manière et qu'elle devient la plus interopérable possible.
Je pense que l'affairisation des données, ça va contribuer aussi à rendre réutilisables nos données et à les rendre visibles.
D'une manière générale, partager les données est devenu quand même, surtout pour les jeunes générations de chercheurs, une priorité, une prise de conscience.
Je pense qu'il faut continuer à organiser des stages, à organiser des rencontres au niveau, pas seulement européen, mais international.
Donc je pense que c'est une forte opportunité pour se pencher vers des directions nouvelles. Et ça donne envie, en fait. Voilà.
Okay. Well, good morning, everybody. I'm happy to be here, and I'm happy to introduce this session dedicated to the EOSC national and thematic use cases after the previous one, that finished with some conclusion that are really interesting from the point of view of communities. Then this is a session fully dedicated to the WP6 EOSC-Pillar. That was the EOSC in action with the participation of different research communities, and especially bearing in mind that the EOSC is an initiative based on the integration and involvement of communities. I think that one of the most important questions is how the use cases can demonstrate the added value of EOSC, but in another way, we can say also how EOSC can provide some support to the communities. For that, I would like to start from the conclusion presented by Jill before. I think also that it's really important to work together. Then we have centered our works, especially around the power of working together among different use cases, among different communities. We have tried, of course, to break down silos. We have tried to, of course, to develop some communalities among different use cases and communities. I think that it can really interesting to synchronize solutions and eventually among communities, but also among different projects in the EOSC-related context. For that, the session today will be normally split into different subsessions. The first one we are going to have the presentation of the posters that are outside of the auditorium. Really short, of course. And then for that, I would like to invite the WP6 community to join me on the stage for the presentation of the posters. The second, you can come, of course. And the second part of the session will be normally dedicated to the roundtable with the participation of representatives from the 4 different regional infra-EOSC projects, EOSC-Pillar, of course, but also EOSC Synergy, EOSC Nordic, and NIFOS Europe. Then this schema is very well known, of course. It's just the mission and objective of WP6. I would like just to put in evidence something that was the main point of our action, as I said before, is the cross-cutting approach. Is of course cross a trans dimension, cross community, but cross boundaries and transnational approach. International collaboration, as Jill pointed out before, is really a success in per se, of course, of this kind of project. For that, I would like to point out this dimension and these keywords that were really important for us within the framework of WP6: cost-cutting, scalability, genericity. Of course, we have tried to do all of this. But I think that it's important now to leave the floor to the WP6 community to present the different posters and to present the major achievements from the use cases within the framework of WP6 EOSC-Pillar project.
They can also have a seat. Okay. Shift to the presentation of the poster.
Or I think. Oh. Yes. Go down.
Very first.
Hello, everybody. We will present the use case one. The aim of use case one is to elaborate cross-domain and fair-oriented procedures and recommendations to enforce. Okay.
The wrong poster.
Okay. Sorry.
Thank you, Rob.
Yes.
So the aim of use case one is to elaborate cross-domain and fair-oriented procedures and recommendations to enforce data provenance, taking into account needs coming from two scientific domains, one on material science, nanoscience, and the other one on climate science. In such a context, W3C Prov standard was used as a high-level standard to track processes and responsibilities as well as to describe provenance in these two use cases. So two case studies. The first case study is on material science, nanoscience domain. Here we implemented different aspects of the FAIR principles on a scientific archive of scanning tunneling microscopy images at CNR IOM in Trieste. We provided different tools and services to improve the overall value of the data set. And on top of these services and tools, we applied W3C Prov standard to describe the provenance metadata. Now for the second case study, I will leave the floor to Marco and Fabrizio. Thank you.
Hello, everybody. Oh, you can... No, it's still the first poster. Yeah, if we now look at the right side of the poster, we can see the representation of the climate science community. And in climate science, we use many different data sources like climate model data and observational data. And this leads to very complex workflows, which require provenance information in order to ensure reproducibility. We addressed the provenance on two different levels. The first provenance level addresses the whole end-to-end workflow. And possible outcomes are, for example, a nice human-readable photo, which you could see on the right side, which shows you the history of the data. And also an XML file, which can be interoperated, here, which is machine interoperable. Yeah.
The second level provenance basically concerns the possibility to explore some first level task with the aim of getting more detailed information about this task. So basically, here is an example where we track the second level provenance for climate index computation workflow, which can be considered, which can consist of hundreds of analytics operators. So this was a proof of concept applied to climate science, nanoscience, and material science use case, but can be extended, adapted, and reused in other domains with the main goal of enabling reusability and shareability, thus fostering opportunity for open science and FAIR principles. Thank you.
Sorry. Okay. So I'll very briefly introduce the result of the okay. Thank you. I'll very briefly introduce the result of our use case, which was about, which involved the five partners from Germany, Italy, France, research performing infrastructure and computing infrastructure. What we tried to solve there with this use case was how to facilitate the work of scientists, so researchers, data analysts from Earth system and environment communities that want to perform cross-domain, cross-sources, and inter-domain analysis of big data, voluminous big data from Earth environment, Earth observation and environment data that are very heterogeneous because they are coming from different disciplines, they are of different types, so can be collected by in situ types or satellite or models or simulations. And they are all stored in distributed domain or discipline-dependent repositories that are managed by several national or European infrastructures. So what we have developed with the use case is a proof of concept of a FAIR-enabled virtual data analysis platform that allows the user to discover data more easily through one cross-domain data catalog that is powered by the Federated FAIR data space service provided by the project. And so the user is able to discover easily data sets coming from different catalogs with a specific spatial and temporal area of interest. The user is also able to access a web processing environment, Jupyter-Hub web processing environment, that to perform on-demand data analysis and processing. This web processing environment is powered by the D4 Science VRE service and IT resources provided through the project also. And so the user can access a full stack of Pangeo software stack and libraries that are very useful for big data analysis of geosciences data. And he can also access ready-to-use data sciences Jupyter notebooks that have been developed by the use case partners in order to perform, to demonstrate how to use those Pangeo software stack to easily and rapidly analyze distributed heterogeneous data from the communities. And finally, which was one big point of the use case, is remote data access. So through the virtual data analysis platform, the user is able to on-demand read and access on-demand data from the distributed repositories in analysis-ready data structures, so made available to the user for him to easily compile those different types of data. This is made possible through some data services such as OpenStack Swift, so it's for climate data, and iRoad service for tested for the ocean data. So what we've demonstrated with this is that first thing is that this concept is very useful and has been validated by the communities to meet this challenge. And also the Pangeo software stack has proved very useful to implement for big data analysis of those type of environmental and system data. But we had some improvement made still. Regarding data discovery, there is a need for better mapping into a common metadata model. Even so, we tested the GeoDCAT model and it was quite useful. There is also a need to better link discovery metadata and data analysis metadata in order to better enrich data description and verified it even more. We also had encountered some issues with data access, remote data access. By implementing iRoads, for example, we encountered issues with infrastructure security measures. So this needs to be explored even more. And finally, we've tested this in a small test, I would say, within the project, but in order to scale this to further use, the virtual data analysis platform infrastructure need to be improved to allow for bigger server options and also to match the needs of users regarding parallel computing. So thank you very much.
Thank you. So use case 3 was initially branded as the agri-food use case. However, like use case 1, we quickly switched to be more repository based rather than the focus on agri-food, using an already generic repository on multidisciplinary, but with the idea of expanding every demonstrator we made also to instances of repository. So based on the scientific use cases, we had 3 keywords that drive the subtasks. One was discovering the data, which translates in data discovery, unsurprisingly, analysis, which translates in the subtask cloud computing, and preserve, another easy one, which translates in the data preservation subtask, with a 4th subtask, virtual research environment, which encompasses aspects from several keywords. So to give a bit of an insight of the work done for the various subtasks. Yep, I'll let you switch. Thank you. For the data preservation one, which is not on screen, we made a proof of concept of a workflow of archiving from the repository to Vitam platform at CNES, which we were able to test on production data. And then we leverage this platform to have the connection to other EOSC services. On the data in the cloud one, which was another big aspect of the task, the idea was to provide on-demand instances of computation platforms like EOSC-Hub, for example, for the users, and not only from, as you see, a UI where they can tailor it to the specific needs, not to use too much resources, but mainly directly from the repository, so that we can link furthermore the data and the computing, and with also tools to get the data back. So this is the subtask where we encountered most difficulty in implementation, with some platforms being hard for the on-demand deployment part and some hard to connect, depending on the maturity level and responsiveness of the technical teams at the platform. But we managed to also, it's easier like that. Sorry, to have mainly the EOSC-Hub connector working and other demonstrators. For the data catalog, I won't repeat the aspects you already seen, with the catalog being in with the catalog Leonardo presented, or the F2DS, which we will further develop this afternoon. But not to just mention this aspect, we also were able to expose the data from database-based repository into Fraunhofer Material Science new marketplace. And finally, for the virtual research environments, which I'll also be quick on because it's some of the work that were presented, we work both on opening the virtual research environment with Leonardo team to other computing infrastructure, and of course, getting the data in the repository to the virtual research environment. So to give you quick perspectives on what this demonstrator might become, of course, as I said, these demonstrators are reusable for other repository instances, but were developed with the INRAE institutional repository as a first use case, which is now France whole research generic repository. And we plan to implement some of the demonstrators, or get the ideas from the other demonstrators to implement them services and integrate it better within the EOSC ecosystem.
So how do I scroll without 2 fingers? Okay. So hello everyone, I'm Stefano Zacchiaroli from Hingria and the Software Heritage Initiative, and I'm here to present briefly the use case 4, which is software source code preservation, reference, and access. So for context, the Software Heritage Project is an archival project in which we archive all the software source code we can find together with its development history. It's the largest public archive of this kind of software artifacts in the world, and it's something we created in collaboration with UNESCO. So essentially, if you have ever used a Git repository or any other version control system, if that information is public, we can archive it in Software Heritage and make sure it can be recreated from scratch in case it disappears. In the context of EOSC, we've worked into essentially building services and API on top of Software Heritage so that researchers that want to archive software source code can do that, integrating with the Software Heritage Archive. Our view is that in open science, you basically have 3 pillars, I dare say, in this context. One is open access to publication. One is open data, access to the data used or produced by experiments. And another is essentially access to the software source code, which has been used or produced as part of an experiment. So we have essentially provided standardized, integrated, and provided several services to other EOSC partners. One is the ability for researchers to deposit actively software source code in the archive. So via authentication that can be and has been integrated with other tasks in the project, researchers can essentially say, this is software source code I produced as part of my experiment, and deposit it directly in the Software Heritage Archive. And we have created API to retrieve software source code that has been archived in the past, which is, of course, is something that is needed after archival if you want to access the data later. And as well as worked on to essentially integrating long-term preservation with other partners of the project. I'm getting back to that in a moment. And the ideal workflow, which is the main one which I'm going to present here, is that researchers can use existing open access platforms for publications such as HAL, which is also part of the project. And essentially they can deposit their papers there and associate to their papers software source code, establishing a link that says this paper has used software source code, which is in this attachment or any other artifact you can associate to your paper. What happens then is the open access platform, through a protocol that we have standardized as part of this project, pushes the software source code to Software Heritage. The software source code is archived there, and a persistent identifier is sent back to the open access platform such as HAL. And that creates a link that allows both from HAL or any other open access platform to see what the source code used for this experiment. And vice versa, when you are visiting the Software Heritage Archive, you will have a link saying this software source code comes from this specific research paper. So this has all been engineered and integrated. And the last point I want to mention here that we have also worked on standardizing the identifiers that are used for referencing software artifacts. And this is come under the name of SWID for Software Heritage Identifiers, which are now registered as a URI at IANA and in the process of becoming an ISO standard. And essentially using SWIDs, you can reference at different granularities software source code. You can reference an individual source code file, an entire source code tree, a commit in a version control system, and so on and so forth. And these are the handle that you will find associated to your papers on HAL or other open access platforms. I'm not going to enter into detail, but we have also standardized APIs. So all that you can do interactively via web interface, you can also do via some web-based APIs that are documented, and you will find links to them in the final report. And finally, we have worked together with CINES, another partner of EOSC, to essentially make sure that we can store essentially a cold storage version of the entire Software Heritage Archive, which is quite sizable. It's about 1 petabyte of data as of today. And essentially develop a prototype on how we can archive that in the VTAM platform, essentially for disaster recovery. So if it will ever happen that the Software Heritage Archive and all its live copies will go away, we will be able in the future to reboot it from the VTAM platform. So that's it. And there's the poster out there, and I'll be happy to discuss with you in front of a coffee or later in the question time.
In this use case, we deal with SSH communities, so data lives for humanities, social sciences. And it's a strong partnership between two main infrastructure for open science in France, CCSD, and which is the Center for Direct Scientific Communication, a unit of CNRS, INRIA, and INRAE, and Humanium, the strong open science infrastructure for social sciences and humanities. So in this use case, we built a proof of concept to establish a bidirectional relationship between publications deposited in HAL and data set from SSH communities deposited in Nakala, produced by Humanium. So to build this proof of concept, we use some principles. First, we decided to use, of course, persistent identifiers to establish the relationship. So DOI in Nakala and HAL ID, which is a persistent identifier too. And we used a standard vocabulary. We used DataSite to type the relationship between publication and data. And we use API in HAL and Nakala to add a relationship to search some, for example, in Nakala, we search dataset to link with publication. So how it works, we are, for example, in HAL, a researcher can establish in his publication, so he has his publication, and he can search through an API, a dataset in Nakala, and then the relationship is, so he search, he can browse the dataset and choose one to link with, or two, some datasets to link with his publication. Then, of course, the DOI of Nakala dataset is present in the landing page of the publication in HAL, and you can see if, for example, you have images, you can see it, a preview in HAL publication. And we use, because when the relationship is established, we use a protocol, a communication protocol, which is called Mercure. So we have to install a Mercure server in Nakala, in Humanium, to synchronize the relationships and the data in HAL and in Nakala. So if the relationship is established in HAL, in the publication in HAL, HAL is sending a message through a Mercure protocol, and Nakala can come and establish the reverse relationship in Nakala. So Mercure is a really real-time communication protocol. So the researchers can easily establish the relationship between publications and dataset. HAL has a strong community of social sciences and humanities communities. So Nakala is for these communities too, but we think that we achieve 3 goals with this proof of concept. First, we link publications with data stored in a structured and fair way in a secure repository. We break the silo between publications and data. I think it's a model to link with other data, for example, in these communities, but other communities too. For example, we can imagine we will create this relationship between publications and data in other communities, maybe with this protocol or other protocol. And we promote and make accessible open science and fair data processes and services with this proof of concept.
I know that it's quite complicated to summarize 3 years of development in 3 minutes, but please,
I'm trying my best.
Thank you.
Hello, everyone. So today I will reintroduce our poster on use case number 6. So our job is like to firstly to imagine, to establish the link between the different services that have been provided in the EOSC-Pillar project, and also to test and to demonstrate this workflow and to give feedback to our partners. So the different services that we've been using here is Galaxy, which is a well-known workflow system in bioinformatics. So to ensure this demonstration, we established 4 theoretical scenarios, which is like the first one is to deploy Galaxy in a public repository near to the data. The second one is to deploy Galaxy in a private, just near to the data center. And the third one is to deploy Galaxy in a private and secured infrastructure. Our fourth scenario is to make sure and compare the results, the obtained results, and make sure that we will have the same results. So these different strategy or different theoretical scenarios was based on either the researcher recommendation or data security requirement. So for that is like to test our workflow, we use 2 different data sets. The first one, which is a Thematic variant data set calling, I will introduce it later for you in the demo. So which is a light data set used to train in bioinformatics. And the second data set in real life, we are introducing a real life problem, which is the ACNV data set, which I invite you, if you have more questions later, to join us in the coffee, so you can learn more and you can see more. Thank you so much.
In the meantime, hi, my name is Javier Quinteros. I will introduce use case number 7. I will try to keep it under 3 minutes. This has been developed within the context of the seismological community. The seismological community is quite advanced compared to many other branches of science in relating to data management. We have a standard for data format exchange, for data provisioning systems, all these type of things. So when a seismologist goes with a seismic station to a remote place like a mountain, an island, and they deploy the seismic station, they know exactly what they should do then with the data when they come back, how to archive that, how to provide that to the community, then what can go wrong. Well, actually, someone realized that there is kind of a game changer, some disruptive technology that it's called an instrument that is called an interrogator, and that someone realized that if you plug it in a fiber optic cable, the one that brings internet home, usually the one that we have millions on the below the cities and even in the ocean, then you can have the equivalent of a seismic station every 2 meters. So this is kind of challenging for the community, of course, because that means that a single researcher could generate petabytes of data in a year. Who is going to host it? How is it going to be provided to the community? So what we actually led is an international effort within the context of this task, including France, Germany, USA, and some other data centers in different directions. First of all, in order to participate in international forums and to guide the community, the international community, into the definition of new standards. But on the more concrete side, actually, what we are providing here is a service and a software package is equivalent with container technology that standardize automatically all this information and put it automatically in the community with the standards that are defined today until the moment actually that the new standards will be defined. So I hope, of course, more details you can get in the poster. And the introduction for the use case 8, this is outside of this is more generic. I mean, has nothing to do in particular with the seismological community. Many years ago, we started within the context of the RDA working group to work on the specifications of a research data collection system. The main idea behind that, it was that in times of big data, for instance, still in some journals, well, there are many reasons for this, but I would like to mention only one at least, or a couple. Even in times of big data, still when someone is presenting a paper to a journal editor could tell you, okay, you analyze 1 petabyte of data, I would like a link so that anyone can download this data, something that is completely unreasonable today, in particular because it's impossible to freeze this 1 petabyte of data if you did some data curation on top of that. So there are other examples similar to these, why actually one shouldn't instantiate one data set, but should be able to reconstruct it and to define it in a particular way. For us, a data center that is producing or delivering to the community 100 million data sets per year, it's impossible to keep a copy of these data sets in the let's say for the sake of reproducibility. So we also need a way to define these data sets without having to make a copy of those. On top of that, we wanted to have functionality on top of that, machine actionable collections where you can dynamically make it larger, improve it, or add some heterogeneous data on top of that. In the end, the specifications had been published, and what we did within the context of this task is to build a generic multidisciplinary system based on the experience of these 13 communities at that moment of the RDA working group. And we are also providing this system with containers technology so that anyone could deploy that. We are ourselves also providing this system since a few weeks so that if anyone would like to test it, also they can use it. Thanks.
I think that we can pass directly to the final poster, the poster number 10, because I'm not sure the colleagues for poster number 9 were available to attend the meeting today. Then we can pass to the open call poster.
Okay, hi everyone. 6.10 is about an open call for thematic services. It has been launched by September 2020 with the main aim to engage with other, let's say, disciplines, except the existing ones we had on work packet 6. And based on that call, we received some applications, and after the selection process, we accepted 5 services, let's say, so-called use cases in our project. And you can have like, not completely done, yeah, it's okay. So they are, oops. Yes. The 5 services that we managed to onboard are called the Ethnic and Migrant Minorities Survey Registry, sorry. And the second one, it's called MMODA, Multi-Messenger Online Data Analysis, which targets actually the astrophysics community. Then I need to go down. Read metrics is the third one, to analyze basically usage across different disciplines and consortia. Simbat, the fourth service being accepted, is a reference database for the nomenclature and bibliography of astronomical objects. And the last one was Thoth, which is an open metadata service for open access books. And that the support, let's say, we provided to these different service providers were quite different, I would say. Some that the main supports I can mention were to interface the service with the instance we had for the AI, the authentication and authorization infrastructure provided by Pillar, and some other support for helping them to onboard their service to the EOSC portal and marketplace. And well, as a result, we were quite happy because 3 from these 5, let's say, services managed to onboard and to register their resources to the EOSC portal, and they are the EMM Service Registry, MMODA, and Simbat. If you want to know more about each of them, I think there's a poster, and for each service you have like a QR code that will redirect you to the URL source of each of these services. Thanks.
As you understand, we didn't schedule any QA session for the poster and use cases, but they are available, of course, if you have any question to discuss with you during the other session or during the breaks, of course. Then many thanks to all of you. I'm really happy to meet you finally in person here in Paris. We worked a lot during the last 3 years. And it was really hard to summarize in 3 minutes your results, achievements. They are quite different one from another, but they are excellent. I think so. Then thank you very much. And yeah, thanks. Then, as I said before, we are going to pass very quick to the second part of the session that is dedicated to the roundtable. Normally, I would like to invite some colleagues from Pillar to join the stage, to join me on the stage, and colleagues from the other projects. I would like to invite Adeline Joff from Pillar, Javier Quinteros from Pillar, of course, Annabella Oliveira from EOSC Synergy, Adil Hassan from EOSC Nordic, and Andreas Antenodou. Perfect. Perfect. Thank you. Sorry. Well, just come on. Just to introduce our colleagues, I know that they are well known by all of you, but you know, Adeline Joff is a research engineer at CNRS here in France, head of international cooperation with the French research infrastructure Humanium, dedicated to social science and humanities. She's involved in a lot of French initiatives, but also a lot of European Union H2020 Horizon Europe project dedicated to the infrastructure and data, and of course is directly involved in the development of use case number 5 in Pillar and WP6. Javier Quinteros is the manager of seismological data center Geofen in GFZ in Germany, head of EIDA. The chair working group of members of the EXOCOM of the International Federation of Digital Seismological Networks. He took part in a lot of projects in the European context. Of course, we know that he's directly involved in WP6 and he powered and leaded 2 different use cases, number 7, number 8. I would like to thank the colleagues from the other project, of course. Annabelle Oliveira is the Head of Information Technology in Water and Environment Research Division of LNEC, probably, okay. The National Lab for Civil Engineering in Portugal. In the last year, she has participated in several EOSC-related projects such as EOSC-hub, EOSC-Synergy, and EGI-ACA, with a focus on development of the open cost and WorkSeeker services. I know that we are going to introduce the WorkSeeker services and the other services implementing, developing within the framework of the Synergy project. Thank you very much to be there. Andreas, of course, yeah, is an associate research scientist at the Computation-Based Science and Technology Research Center, CASTOC, at the Cyprus Institute, working on computational high-energy physics. During the last 6 years, he has been working in leadership position in fastest European projects such as VSIM, and currently in NIFOS Europe as the leader of the work package, which focuses on user engagement, training demonstrators. Thank you to be there. Adil Hassan works for Sigma 2 AS Norway and looks after the research data archive and other data management related activities. He works in EOSC Nordic and helps out in the work package tasked with the demonstrator for cross-border research in the Nordics and Baltics. He has a reasonable amount of experience in large volume data management. He also worked in different countries, such as the USA, UK, and Japan. Thank you very much, Adil, for joining this roundtable. Thank you very much to all of you for having accepted to take part to this discussion. It's an open discussion with the audience, of course. We are going to address some topics, of course. We start at the beginning with the question, how the use case can demonstrate the added value of EOS. Of course, we are going to talk about some dimensions that are important within the framework of the European Union and in the framework of EOSC, is the involvement of the different communities and the community's engagement, but also beyond your communities, because we know that we should develop some approach that can be interdisciplinary. And of course, one of the main results from this kind of project is the transboundary cooperation and international cooperation. That is important. That is in per se a great achievement, but it can also provide some constraints. Then I would like to have probably just an overview, just your point of view on 2 different points. Focus on transboundary cooperation, international cooperation, and eventually on interdisciplinary and the collaboration among communities and within your communities and beyond. Eventually in the different projects you are involved in, and we can start. We already understand a lot from people from Pillar. Then I would like to start from colleagues. Eventually, Andreas, a point of view from the NIFOS project.
Thank you. Yeah, just be sure to speak very close to the microphone like this.
Can you hear me now?
Like you're eating an ice cream.
So yeah, so in NIFOS we had let's say an approach which involved 4 different flagship communities: life sciences, oh, it's okay, climate science, digital cultural heritage, and computational physics. We know that these 4 communities are highly interdisciplinary. I mean, we have seen in the past, I mean, through networking, that these 4 communities can work closely to address, I mean, important questions, I mean, regarding scientific also issues which address societal, let's say, challenges. So this is the first way to approach an interdisciplinarity framework. Of course, the scientific community leaders design use cases which have involved researchers from all across the region, the NIFOS Europe region. And again, I mean, also the fact that it has a regional character. This has helped a lot because, I mean, different regions of Europe, have, let's say, a lot of similarities in, let's say, weather, in archaeology, for instance, also in life sciences. So this kind of brought, different scientific groups from all across the region together to work on particular topics. So, for instance, the use case which has run in digital cultural heritage involved researchers from all across, not just NIFOS Europe, but all across Europe, as well as the US, Canada. In addition, the computational physics, which is highly interdisciplinary, appear to be also a cross-border use case. Because let's say researchers from all across Europe were involved, especially from Norway and Germany. And of course, climate was proven to be cross-border. We had researchers from Armenia, Georgia, North Macedonia, and Serbia participating in this use case. And in addition to that, we also had the open call, which is, let's say, an evolution of the use cases. So the use cases, the idea of having the use cases was first to test, let's say, the services and the solutions that were first onboarded on EOSC. So we wanted to test whether they have been onboarded according to EOSC, let's say, principles, as well as they are of a high TRL level of 8 and 9. And this has been, it was clear that this had been achieved through the use cases. And then we invited researchers from all across Europe to participate in the open call. And we actually had 20 applications accepted from all, from 11 countries from the NIFOS Europe region, as well as 3 applications from Spain, from Switzerland, as well as from Germany. So I would say networking has appeared to be to play a key role in the border character of the use cases and the open call, and the regional character of the project as well. So that's all from me.
Yeah, thank you, Andrea. It's really interesting. Every region is quite different from another, and then every project is quite different one from another. Then probably a point of view from the Nordic. And Adil, something to add from your point of view on these questions?
Okay, if I can remember the question. I should preface by saying that the important people are, of course, not here. The ones with all the information are my colleagues at EOSC Nordic. I'm just a chocolate teapot, so rather less useful. For the cross-border work in the Nordics, it's difficult. And the problems are mainly to do with policies. So if you're trying to run jobs from Norway to Sweden, then you have the issue that maybe there are computing centers in Sweden that will not allow you to run jobs because there's no train of what's it called, some traceback of authentication as to who the job, where the job came from. And then there are other issues as well to do with that. One of the interesting things, of course, is that researchers, as you guys are all researchers are aware, are very much like water, my friend. They find ways around these issues. some legal, some maybe not so. But really, policy is a big problem that we have to deal with. And as far as cross-disciplinary work is concerned, that's also difficult. The issues there are that we've seen that there are, say, some disciplines that have got some money to set up some services. And then you find that, for example, with the Galaxy portals that are from the life science, the bioinformatics and life sciences people, and then you have climate scientists that are very interested in using those. And now you have the problem that they want to add their libraries and their codes to this. So you have the issue that, oh, this is very nice to do, but who's going to pay for it? Who's going to pay to look after these libraries and maintain them and make sure that they're up to date with all the security patches, etc. So that's an issue that comes up as well, which is the sustainability of the services once they start to go beyond the remit of where they were originally defined. That's, yeah. So.
Thank you, Adil. Just a question: how have you dealt with this kind of problem in terms of policies constraints or legal constraints? Have you identified some solutions or not yet?
We've within the work package 2, which works on the policies and those aspects, they have been gathering together the people with enough influence to at the sort of the governmental level to look into these issues and try to figure out ways to address this. Of course, one way of getting around that is this Lumi supercomputer in Finland, which of course the Nordic countries and Baltic countries have been contributing money to, and so they can use this one resource. But within the different countries themselves, the computing resources in those borders, they've been trying to look at ways to address that, perhaps with some sort of tokens that are agreed by the different countries. But it's well, as you know, politics moves at a sort of glacial pace, so it's a slow process.
Thank you. Yeah, you raised a question that is quite important. That is the sustainability. Of course, we are going to have a session later in the afternoon with a focus on sustainability within Pillar. But we will come back to sustainability. I think that it's quite important. But I would like to have the point of view from the EOSC Synergy project, then Annabella, because Synergy is quite different project, based on some requirements from communities. And I would like to have probably your point of view and how have you developed services and how have you developed these interconnection interfaces with other communities within the communities involved in the Synergy project.
Thank you. I'm going to bring you the view of a researcher. I'm one of the people in one of the thematic services of the Synergy. We have 10 different thematic services organized around the 4 areas that you see on the screen. Each of these services has their own research community, and these communities are typically transnational. But the challenge here was to bring this transnational context towards also the infrastructure part. So making people from the research communities working with the IT people, if I can say it in a very simple way, to transform tools into services that the society can use. And that was the challenge, because most of these thematic services had some common problems to solve, like, for instance, authorization of users. That's a common problem for all of them. And the goal of the project was to bring in all these requirements from these different scientific communities into making them take advantage of the developments that were being done for previous projects in using infrastructures in a very meaningful way. So in the end, we wanted to have better services that were taking advantage not only computational resources, because some of them already did that, but to use all the core services that are available. And by doing this, taking advantage of the national infrastructures in an integrated way, and to have better services in the sense that we wanted the software quality to be controlled, and we developed a service for that. And this was done in a cooperative way between people from several countries involved in the project, and also to make sure that the data that is generated in these thematic services, and some of them generate a lot of data, like those related with Earth observation, to make sure that this data comply with the FAIR principles. And to do that, we developed a specific service to assess the fairness of the data being generated, both the data that is collected and the processed data. So in the end, this is a circle of cooperative transnational work that worked very well. And I'm going to talk a little bit about the service that I'm directly involved in, Warsica, and which deals with detecting water interfaces in the globe. For instance, detecting a coastline, detecting a lake. And through the cooperation between the researchers from France and Portugal, we were able to develop a new methodology to map topography in areas that are very difficult to do field work. And our use case was the Amazon River. And we developed a new methodology that is now integrated in the Warsica service, and that can be used anywhere in the world. So this cooperative transnational common research was able to produce services that can be used for Europeans and anywhere in the world in a very simple and user-friendly way, where all the complexity of the EOSC services and resources, which are fundamental to achieve these results, it's all hidden from the users. Users interact with interfaces, simple interfaces that a coastal manager is able to use. We don't want people to spend a lot of time trying to understand how to use the service. So we put a lot of effort in those user requirements. So it was the focus of the project, quality and user friendliness.
Thank you, Annabella. It's important what you stress is important because you pointed out the importance of taking into consideration users, and of course we are going to develop services to be used, and then it's important to have this in mind. Especially when you are dealing with global challenges such as water, management of water and water resources, of course, but probably I would like to have the point of view from Javier. You are dealing also with global challenges. You are dealing also with a huge amount of data, and eventually, what do you think about the users, and what do you think about the other point that is stressed before, the sustainability of the services?
Yep, thanks. Can you hear me properly? Yeah, I think that it's pretty interesting, all the concepts that have been introduced here in the discussion. And I would say that there is a common point to some of the problems that have been mentioned, and it's the definition of standards. At the beginning, you mentioned two concepts, that it's the transnational access and the multidisciplinary approach, probably. There is no such a way, or there is a hard way to achieve this if there are no definition of standards. And here's the first problem in the context of a project, is that it's impossible to get into the same project to a whole community. You usually get 1, 2, 3 key players. So it's important to have at the very beginning of the project the idea of if the effort that someone is going to do is going to be adopted already by the community itself, even if it's the best product in the world or not. Then after the project, you need to convince the other ones to adopt it. Because if you enlarge a little bit the landscape and you define standards, or you foster the definition of standards and you involve other players that could be part or not part of the project, then you're winning, first of all, sustainability, because that when you have a standard, it doesn't matter if the project ends and we all retire. I mean, it's a standard. The whole community will support that. That's the very first important thing. Then that helps you a lot in the discussion of transnational access, because if it's standard, it's a standard without borders. And regarding the multidisciplinary approach, if you cannot even within your community define a standard and so that we all work in the same way, how can you work with people from other communities so that we can share data or services or things like this? And AEI that has been mentioned here, it's a really nice example because it's a service that is pretty basic in the sense that it's technologically complicated, but the concept of the service, it's pretty basic. And there are different approaches. And in the last 10 years, we've seen how this has evolved and achieved a kind of a common solution with similar approach with blueprints that Europe has adopted. And it has been mentioned by Adil already. There are also the human factor, the definition of a common way to represent tokens and the information that is going to be there. This is pretty important to cross borders, and so that these tokens can be accessed. And that comes, of course, to the hand of services. Yeah.
Thank you, Javier. And the last, not the least, the point of view from the social science and humanity community representatives in terms of this point of cross-community, trans-community, eventually the question of standards among the different communities. You and your colleagues within the framework use case 5 in Pillar, you have developed or tried to develop several use cases, the interfaces with other communities. Just your point of view, your experience on this question, please.
Yes.
Thank you, Adeline.
Yes, it's very interesting. Really, a lot of things has been said yet, but about I mean, the idea and the concept of standards, of course, leads me to think about community engagement and how did it become a standard? It's because it is useful, but it is because it is used. So it is shared between a community. And what I would like to add about this topic on the question and what I felt about Pillar is really to deepen the knowledge between us first, because, for example, in social science and humanities, it is such fragmented communities. Indeed, it is not. You can't. Indeed, it's quite difficult to. I know we used to speak about community, SSH community, but I would like to say that SSH community does not exist. It's really a hard work, and it's something that you also find in the type of data managed, for example. So it is very the side of community involvement and co-creation that was also mentioned this morning. For me, it's really important. It's a key point. And I think this kind of project focused on national initiatives, but which also allows to share experiences from other countries, from other regional projects. For me and for us, I think as a research infrastructure was really important because, for example, if I take our example, we know other national and French infrastructure. We know them. We used to exchange with them, but in reality, with the CCSD, for example, is the first time that we really make something together. I mean, the concrete aspect also is a starting point to be able to know deeply the other and to be able after that to build more and to have a common vision. And I think it's a really important added value for this kind of project focused on national initiatives too. It's really about taking care of what is done by the others, and for example, for the SSH point of view, to be able to know other infrastructure in other domains and to start discussing about using, for example, their services, because SSH communities are more and more on demand of IT services, for example, and some other labs and infrastructure are already developing this kind of services. So the idea of each European project is at least the same, not reinventing the wheel. So we have to force ourselves to do this kind of, or to comply with this kind of approach at national level too. And I think it's also opens our minds, and it makes our practices really evolving. It's what I felt from the EOSC-Pillar project, but also in our everyday working life.
Thank you. Thank you. We thought this session as an open discussion with the audience. Then I would like to go through the audience and see if there's some questions from you. Some questions? Well, just. No, yeah.
No, it's okay. Let me. So like this.
Thank you. Yes, I was wondering, seeing all these services being developed in different or further developed in all the different projects, and attaching to the last remark where Adeline said, well, we need to open or communicate with disciplines that are maybe not developing these services, if I understood correctly, right? So my question is, did the services development that you did in the different projects, did they cross disciplines, or were they born from a certain discipline and then started to cross borders? Was this done by themselves? Did they search for, let's say, more customers, or was it that the customers came to them? Because somehow I think that, I know from my background, that you develop a nice service, you do programming, you have things right, and then you say, well, now guys, now use it, right? It would be nice to hear, if at all, if you did your dissemination yourself and went out and searched for interesting users or interesting opportunities to apply your services or your own service to other thematic areas.
Thank you, Jess. Then, who want to try to? Then, Annabella.
I can start.
Okay.
Well, in our case, what happened was that the work was very discipline related, and through this project we are able to work with people from computer science and bring the notion, the concept to a whole new level. And how was it motivated? It was actually motivated by the users. We had a previous European project where users were partners, and we were concerned about water leakage, so trying to save water from being lost in the main distribution mains. And that promoted the need to look for an algorithm that could detect water presence. So this worked both ways. So the users told us, okay, we need these. We went and developed the concept. Then in synergy, we brought in besides the people from geosciences, we brought in the computer scientists to develop a service that is now starting to be used by the end users, because it has become simple to use and beyond the science domains into innovation. So we did a whole circle of collaboration.
I think Andreas has something to say.
Yeah,
Can you please?
yeah. Andreas. Come on, Andreas.
So I would say that yours, this is a very interesting question. Of course, within the framework of InfraEOS 5B projects, I mean, we are not supposed to, let's say, develop new services, but we could influence, researchers and scientific communities to come up with new services. So the way that we worked in NIFOS is that at the beginning we had these 3 flagship communities, which are more, let's say, there is an interdisciplinary, let's say, connection between them, but not at the level of services. So, but afterwards we decided to come up to identify, let's say, a cross-disciplinary community, a highly cross-disciplinary community, which basically can easily connect, let's say, different communities such as computational chemistry, computational biology, and that's computational physics. And then we invested also in that. And by approaching researchers, we have actually influenced scientific teams to come up with, let's say, services which are cross-disciplinary. For instance, we have created services which are, they combine both life sciences and digital cultural heritage. For instance, we have a service called Sexest, which basically could identify the gender by looking at the sizes of the bones, for instance. But I would say the main cross-disciplinary, let's say, effort was given in the computational physics, in NIFOS Europe.
Okay, thank you. Adil, your point of view.
I'm lucky or unlucky. I look after the sort of the data archive in Norway, and for us we have a lot of climate scientists who are collecting important amounts of data. And one of the questions, of course, that they have, so we're driven by the users, which is the only way to be. EOSC Nordic has allowed them this better communication to happen. So they've been coming with questions like, I'm accessing data here in Norway, but I really would like to be able to access data in Sweden and in Finland. Can you guys think of a way to do that? So we cobbled together a solution for them, which was making use of object storage to integrate it through the Galaxy portal, which they were very happy with. So these driven by the users is really the only way to proceed as far as we can see. And there are other examples as well where we've the users as the ones who come with the problem, and then we've tried to provide a solution. There is another point which gives me the gray hair, and that is the issue that we have lots of very smart users, researchers, and they come with their code, and they say, hey, I've got this nice code, can you put it on your platform? Which we dutifully do. And then they've tested their code on a small amount of data, and now they try and run it on a huge amount of data. And then they find some scaling problems. And then they say, but it's running very slowly. It works fine on my laptop. Can you fix this? And then, you're then spending rather a large amount of time trying to tune this and trying to get it to a performance where it can be better. So one area that seems to be becoming important is these integration experts. So people that are able to straddle between the computer support services and the scientists who would be able to help to address this this problem, which maybe give me less gray hair.
Yeah, thank you. And from Pillar, eventually Adeline, as you work within the framework of a national infrastructure, how are you dealing with this kind of question in a thematic infrastructure, of course, that is essential, especially for the social science today, have integration and especially a cross-border approach with other disciplines and with users coming from other disciplines, of course. We can think to, I don't know, some global challenges, such as global climate change, for example, or climate change adaptation. Then how you're dealing with this question within the framework of your infrastructure?
Well, I will be very short, and I also agree with what the colleagues just said. I mean, the user-driven approach is really ours. But what is interesting, it's, as you say, Annabella, then when you get a level of maturity of the service and also of genericity, I don't know if the word exists, but you understand what I mean. It's interesting to be able to disseminate the approach and try to to get more communities also involved and to use the service, so as you have a kind of virtuous loop circle, and it's really what we observe. So within Humanum, for example, of course we are attentive to the specificity because it's always a discourse led by the disciplines. No, we have very specific needs, so we need very specific tools, and it's our tools, and it couldn't be other. But really, at the end, when you gather them and you organize collective discussion, they realize that their needs are not such far from them and from theirs, and yes, they are also eager to use effective services, and I think they are also now willing to enter this dynamic. So I will say both. I mean, it's really user driven, but also when you reach a certain level of maturity from one side and also generosity, it is easier to open it and to show that, yes, other communities can come in and can maybe certainly bring something. And that's how also the services evolves. And it's linked with the question of sustainability too, that we will talk about later.
Yes, then a question that raised also yesterday in the afternoon, which is the role of users and in the development of the EOSC. Should they be involved since the beginning or eventually after services and the platform implemented? Your point of view, Javier?
Well, on that, the best example I can present is in the use case 7. We started exactly at the beginning of the project with this international effort, and what we published that in a paper. We started with a global survey on big data users for the community, and then we presented the point of view of the users, and in the same paper, the point of view of the data centers. And that was actually the base of the service and the product that we built during the project and that we delivered. So for us, it's really important, as I mentioned previously, first of all, to listen to the users, definitely, but after listening to the users, to define something in common within the community. That's how we ended up presenting these different type of things on the same use case we presented. First of all, software package, but also a service but also not only a service because we are talking of big data that must be run in a particular place, but that anyone can run locally. So for us, this is pretty important. And even we went one step beyond that, and we didn't actually build just our service and our software package. We contacted actually developers from other products so that we involve them and engage them also to take the same approach that we took, so that other software packages could do exactly the same. And that's also one of the ways to build the standard, to a de facto standard in the way. We knew that there could be similar products out there that could evolve in the same direction. And actually we decided, okay, it's probably the best way is at the very beginning to listen to the users and then to bring these results to the rest of the developers and say, okay, let's try to do it in the proper way and have an open discussion on that. And that was pretty beneficial for us. Yeah.
Adil, of course.
Sorry, I think maybe there are different types of users. So in the beginning, you've got the more sort of mad, keen, demented ones that would be interested in taking part and putting the thing together. And then later on, the users that are more sort of interested in using it. But I think one very important thing which we need to try and address is that these people who are beating up on it early or sort of early adopters or things like that, there needs to be some sort of rewards for them. Because these are researchers and their day job is to try and get their thesis or their masters or whatever out. So this additional work needs to somehow be rewarded, which I think is something we really need to take into account.
Yeah, just to comment, I mean, basically, I mean, researchers need tools. I mean, this is what I think will change the whole scene. I mean, we need to provide them tools. I mean, without tools, I mean, a researcher is extremely difficult for them to invest time to, I mean, make the data, I mean, fair. Yeah. So, right, tools is required.
Right. It is a really interesting discussion, but we are arriving at the end, I think, but probably we have time for a last question from the audience, if it is the case. No questions. Then I would like to thank all of you for having accepted and participating to this roundtable. Thank you very much for your inputs and feedback. It was really interesting. I was wondering that we should do it before than at the end of the project, but it's great to have this opportunity to discuss today about important topics for the future, of course. Thank you very much and enjoy the meeting. Thank you.
Right, so now we're heading to lunch. I suggest we get a move on. It is outside the BNF, so please do follow us. Let me just see if I can show you the direction really quickly. Right. So basically, here we are. We're going out from the BNF, and basically we have to head towards the river. Here there will be basically a crosswalk, and yeah, basically the place is here. Okay, so please follow us. I suggest from the place, after you finish your lunch, please start heading here by around 1:45, or let me just check. Yeah, that's right. So 1:45, start heading here so that we can start promptly at 2. Thank you.
European Open Science Cloud, the main initiative of the European Commission to promote open science and support research in Europe.
We are creating a European Open Science Cloud now. It is a trusted space for researchers to store their data and to access data from researchers from other disciplines.
The EOSC Association was created in 2020 to provide a single voice for advocacy and representation for the broader EOSC stakeholder community. Promote the alignment of European Union research policy and priorities with activities coordinated by the association. Enable seamless access to data through interoperable services that address the entire research data life cycle, from discovery to storage, management, analysis, and reuse across borders and scientific disciplines. Currently, more than 200 institutions spanning over 27 countries are members or observers of the EOSC Association. EOSC aims to make it easier to find, access, and reuse research data, tools and services by connecting digital infrastructures to provide seamless access to research data and services for the scientific community. This goal will ultimately be achieved by providing an environment where European researchers from different scientific disciplines and countries can work together more efficiently. This web of research data and services will make research more innovative and impactful. This rich ecosystem is being implemented through several projects funded by the European Commission, which work together for the common goal of getting EOSC ready to foster fairness of data and services. Possible tools to connect to EOSC are accessible through the EOSC portal, where providers can register their resources into the EOSC portal catalog. These resources are then made available to prospective users through the EOSC marketplace, where researchers can find resources suitable for their needs. EOSC will have a different value for different actors. EOSC will offer to providers, infrastructures, and researchers the framework and tools to enable sharing, discovering, and accessing the resources in the research ecosystem. Resources can be composed to provide new added value services. A good example of this is the COVID-19 activity, where specific services allowed daily epidemiological data to be made available to all scientists for multiple analyses. As a further step, EOSC core services will allow their integration into automatic analysis pipelines to feed predictive models of major importance for governments to assess the impact of public health interventions. For researchers, the main benefit will be the possibility to find resources suitable for their research activity and combine them with resources delivered by different resource providers. For service providers, the main values will be the possibility to increase the visibility of their services or resources and to more easily allow for their composability with other services, thanks to the EOSC interoperability framework. The benefit of joining the EOSC development for e-infrastructures and research infrastructures is triple. It is the possibility to, firstly, to increase the visibility and usability of the services provided by the infrastructure. Research is about providing and sharing results, demonstrating ability to offer services at the European scale. Secondly, being part of the EOSC landscape is an important aspect to receive future funding, both from the European Commission and on the national, regional, or institutional level. Many roadmaps and policies already give EOSC as one of their objectives, and this trend is going to increase in the upcoming years. Thirdly, improve their activities by leveraging skills and expertise beyond their community. The EOSC community is a strong network of knowledge, and the Commission finances EOSC-related development in infrastructures. The rich EOSC environment is continuously growing, as new service providers and resources are joining the EOSC portal. As of May 2022, there are more than 200 service providers, making more than 300 resources available through the EOSC portal marketplace. EOSC-Pillar helped the agri-food community to leverage existing infrastructures, data resources and services to optimize its workflows. The EOSC-Pillar Use Case 6.3 is based on an institutional data repository, Data INRAE, and illustrates how we can defragmentate such data repositories, thanks to their integration with the services and resources for the European Open Science Cloud. Using the Galaxy platform, made available through EOSC-Pillar Use Case 6.6, contributed to build an integrated and interoperable service for Elixir. All this work contributes to encouraging the adoption of fair data principles in health sciences. It is also demonstrating the added value of the European Open Science Cloud through federated services and common best practices. EOSC will have a value for you. Through the catalog and marketplace of EOSC portal, you can connect and experience it. Enjoy the EOSC ecosystem.
We organized this workshop about national policies, started from EOSC Synergy project with the collaboration of other regional projects. All these projects are reaching the end of their life, and so we have results that we wanted to share with the community.
The session we just ended was on open science and EOSC policies and their counterpart at the national level. And we also spoke about the harmonizations.
They have been chairing a session on funding policies. The purpose of the session was really to understand and discuss the work that the regional projects did in their countries and regions about funding policies.
What the session was about access policies and what the experience from the regional projects was really the practical advice what we have to improve in order to give access transnational, for example, to services and data.
EOSC-Pillar presented two important outcomes, guidelines for harmonized open science policy at national level and overcome some problems on IPR and protection of personal data, and the methodology that has been developed for creating business model for the EOSC services.
So we have to find ways to make policies that are national come together. We have to find ways to have legal regulation that is national come together, and we have to find a way to leverage national funding so that we can build something that is bigger than the sum of the parts, that serves all of Europe, but is nationally owned and nationally funded.
NIFOS Europe supports the establishment of national open science initiatives in 15 member states and associated countries. The regional project model has tangible results in EOSC governance in this region and should continue. EOSC stakeholders should translate to a proper business model. The motto, free at the point of use, does not mean free at the point, free of charge. And we ran an open call for providing access to our thematic services, generic services, and repositories to the broad pan-European research community in order to test the services, engage scientists in open science, and contribute in EOSC capacity building.
The social element of this first big conference after COVID was very good. It's nice for the community. I think overall my impression was the atmosphere was very constructive, very positive. Everybody trying to look forward aligned. And when I say everybody, I mean the projects, the 5B projects, I mean EOSC Future, I mean the EOSC Association representatives that are here, I mean the EOSC Steering Board representatives that are here, and even the Commission who also participated in the event.
Okay. It's not this one.
Oh, no, sorry. Can you put it on? Please put it on again.
No, sorry. It's the right one?
It's
okay. Here you go.
Yeah, welcome back everybody to our first afternoon session, S7 Innovative Federated Fair Data Spaces. My name is Philipp von Hartrott from Fraunhofer AWM. And before we jump into this session, I really would like to thank the organizers for providing us excellent lunch to us. Okay, this session will more or less circle around this F2DS toolset that we have already seen in some presentations this morning. We will have 3 presentations, and so let me click starting with this F2DS metadata repository component. Then we will have a second presentation, which will come remote from Leonardo about the F2DS data catalog service. And third presentation, which will be here on stage again, about the semantic enrichment service. And to wrap all these activities up, we have a little gift, a demo that will be given by the team. We will have opportunity for questions after each talk. And as we are unfortunately a bit behind schedule, I will ask all presenters to squeeze, so right from the beginning. And the first presenter I would like to announce here is Baptiste Touimont from CNES, who will introduce us to harvesting and mapping data to a unifying data space. Baptiste, please.
Okay, thank you, Philippe. So I'm Baptiste Touimont from CNES, and I'm going to present to you the data provider side of the F2DS, which is a service allowing the aggregation, normalization, and semantic enrichment. Okay, so for context now, the need of this service was, so it was very well explained during the first session this morning. So to resume, so the use case is some researcher or scientists may need to search data from multiple data sources. So we had to find a solution to build a service architecture that would support the aggregation and verification of distributed and heterogeneous data resources. So the global idea is to create the condition for an effective sharing, exploitation, and reuse of data across initiative and communities part tagging. So a researcher will be able to search, find, and retrieve data using a single access point and toolset. So on this slide, you can see on the right side the existing tooling for publish fair data, like fair data points to enrich data with semantic, like Semaphora or Fairifer, or some tooling also to evaluate the fairness, like Fuji or Faircheck. Regarding the technical consideration, we focus on metadata and more specially on providing a common format for this metadata and integration of vocabularies and ontologies. So in order to do that, we looked at an existing tooling to improve fairness, and we particularly focus on fair data points. So the fair data point has been developed during the Fair is Fair project, and is enables the publication of fair data using the DCAT model. And the DCAT model was developed by the W3C. So on this slide, you can see the global architecture of the F2DS. So the F2DS is composed by 2 complementary services. So the data catalog service, but Leonardo will present this side of the SDDS after me. And the metadata repository service, which is the topic of this presentation. So the metadata repository is to aggregate and enrich dataset. And then the metadata repository is also connected to the semantic enrichment service. And that will be the third presentation of this session by Jose. So the generic architecture of the solution is shown on this slide. So the idea is to create a data repository layer interconnected together through a federation of APIs. To achieve this, the principle is to build the connector that are described using OpenAPI standard. Thereby, the data repository layer is connected to the smart harvester. And so the metadata harvester uses the API description to automatically harvest the metadata from a repository. So that is that part. The pointer. No. Okay. So I said the metadata harvester uses API description to automatically harvest the metadata from a repository and the mapping description to map the metadata to the DCAT model. So the F2DS metadata repository is also connected to this Elasticsearch index, developed on this project in order to annotate the dataset with semantic concepts. So once it's done, finally, the metadata maps are published to the FAIR data point. And from the FAIR data point, the metadata are available for data consumers. And in particular, they are available to be harvested to the VI. Okay. On this slide, we can see the whole process of the F2DS. So this whole process is based on the user-centric workflow for repository owner. So the first step is to register the data repository by providing metadata about the repository. In second step, the repository must register the API by providing a description of requests needed to retrieve the datasets. The third step is to provide a mapping description through an interface. So it's to map the dataset to the DCAT model. And when the mapping is done, the last step consists to annotate the dataset with semantic concepts retrieved via the index developed in parallel in this work package. And then, so when the mapping is done, the DCAT can be published to the FAIR data point. So on the next slide, I present also this workflow with some screenshots. But the last part of this session will be dedicated to a live demo. But for all the forms we have on this workflow, it's possible to export and import again for another session of harvesting. So the first step is just a form to provide some metadata about the repository. And then we have an interface to describe the API. And so the request necessary to get the dataset. So it's when it's done, it's also possible to export then and import directly to not have to do manually again this process. And then we have the third step. So it's the step to describe the mapping. So I don't know if we can see very well on this slide, but on the left side, there is the DCAT properties. And on the right side, we have to provide the path from the JSON to get the value corresponding. And finally, we have the last step in order to annotate the dataset with concepts. So the F2DS is able to retrieve the keyword if there is keyword present in the dataset. And the F2DS requests to the Elasticsearch index to find the semantic concept corresponding. And it's also possible to add other keywords to find the corresponding concepts. And finally, when it's done, the datasets, the metadata, are published to the fair data point. So the benefits of the F2DS metadata repository, it's we can create in no time data spaces across internal resources, institutions, and domains. There is no changes required for repositories. We can make repository contents more fair. And there are multiple APIs for accessing and processing F2DS content, like Sparkle, REST API on the web UI. And we can connect easily any processing services. So thank you for your attention. So I think we have time for questions.
Thank you, Baptiste, for this nice presentation and for staying really good in time. I think we have time for questions here. Do we have from
remote? So the question from Thomas Genot: would this architecture be usable as a workaround to the current limitations of the Dataverse software harvesting software? Did you explore the use cases involving Dataverse instances? For now, Thomas, if you're connected, I will give you also the floor to speak in case you'd like to ask some follow-up questions.
Just gonna see the question. So the question is, there is a current limitation of the Dataverse software harvesting? No, so there is not limitation. I'm not sure if I understood well the question, but we can harvest the dataset from any repository if they come from API or where we have a JSON format as a response.
Yes, maybe
Thomas,
I
does
can
that answer your question.
Maybe I can precise this. The Dataverse software that is a base for several institutional repositories has severe limitations in its harvesting module. And I wondered if this architecture, as described, would be able to act as a workaround for harvesting repositories that especially repositories that are not Dataverse. So I wondered if you had tried this this workflow on Dataverse instances.
If I tried on Dataverse instance, yes, I tried, and it works.
That is maybe I can add something to the question. No, it hasn't been tried as a replacement for metadata harvesting, which is a specificity for Dataverse, not the relation between Dataverse and F2DS that we made in Pillar, and the proof of concept in this context, will be made in 2023. So we'll test it out.
Okay.
Thank you.
Yeah, small, I don't know if it's a small question, but do I understand right that the first step is that you, as a repository, you need to do the step of matching your metadata schema? That's the first step. So this means that this doesn't happen automatically. It's still better to have like a decapped implementation in your own repository or something. Wouldn't that be easier to do? Or did I misunderstand?
So the goal is to normalize the data, the metadata. So
yeah, of course, but isn't it easier to have as a repository to expose DCAT instead of doing a mapping afterwards, so that you really have in your, I don't know how to explain, but that the DCAT is in say part of your API, that you expose it and that you just harvest it.
Okay, I think maybe Jan have a comment about that.
Did I misinterpret?
Thank you, Hugo, for the question. So indeed, it's best if the repository publishes data as DCAT natively, right? But that's not the case for, let's say, 90% of repositories, right? Or very limited number of repositories. So the idea of the F2DS is to allow these repositories to do exactly that without having to change their API and their internal model in the repository. Because if you want to change to DCAT, you'll have to change a lot of things in the repo. And you don't necessarily have the resources in terms of developer time and things like that. So here you can do that quickly. The only thing is you have to do the mapping yourself, right? So of course, here we're geared toward a repository owner because they are the ones that know better the metadata schemes they're using, their API. But technically, even if, as a scientist, if you go to the documentation, you could do it yourself, right? And the idea is that you can use that to generate a global catalog aligned on DCAT so that you can have common queries based on DCAT. But you have to take that steps. There's no easy solutions, right? So yeah, so we're using the reference implementation of the FAIR data point, but the FAIR data point is actually a technical specification on how to publish your metadata in a repository that relies on linked data standards and DCAT. But if you look at the specs, that's a huge amount of work for a repo to actually be compliant with that specification. So of course, at terms, well, for big ones, I think that diverse, you can get things in DCAT. So that would be no matter, a no-brainer, and you don't have to do the mappings because you harvest automatically the DCAT from the repo. For the others, if you have the mappings, the thing is that the mapping is in a machine-readable format that actually can be exported. So you can develop your own service on top of that and reuse that mappings. Yeah. So it's just to make a quick fix to the situation.
Thank you. Do we have any more questions from the audience or from online? If it's not the case, then let's thank the speaker again.
Okay, thank you. So I give the floor to Leonardo.
Yes. And we move on, yeah, to I think we can gather here because we will at some point all sit here and demo and move on to the next presentation, which will come online from Leonardo Candela. And yeah, is he ready? Can we see him? Can we hear him?
Yes. Okay, so good afternoon, everybody. I'm again Leonardo Candela from the National Research Council of Italy, and I'm going to present, let's say, one other component of the F2DS toolset, the component that was there in order to facilitate the finding and access to the data, and somehow to interconnect this with virtual research environment. So if you see in this picture, you know, I'm going to focus on the data catalog component of F2DS, and it is quite easy, let's say, to realize how, from a functional point of view, this component partially overlaps with the metadata repository that we have seen just presented by Baptiste. Because both of them, let's say, rely on some sort of harvesting in order to populate the data structure that these two services use in order to expose the content that they aggregate. And both of them somehow use graphical user interface that are web-based and API for making available the content that they connect. But let's say these two services, of course, are complementary, and we manage to integrate them, thus to bring added value when they are co-deployed in order to serve let's say, certain task or certain scenario. And we will see how this give a lot of flexibility and how this technology can work together and can be deployed, thus to adapt to different needs. In addition to this, let's say, overlap from the functional point of view, you will also see that the catalog, let's say, bring in some functionality because it is expected to be one of integral component of a virtual research environment. And because of this, it not only give access to some content that have been made available by existing repository, but in case the community didn't manage to find any suitable repository or is willing to publish something for which doesn't exist a suitable repository, let's say, it can use the data catalog in order to create any, I will say, research artifact and to publish it according to the metadata format that the community that is responsible for running the catalog is willing to support. And I hope that at this point it is clear that this technology that you are seeing there is not only for data catalog in a strict sense, okay? Because we have seen that exactly the same technology have been used for developing a catalog of training material, for developing a catalog of services. So it is not just a catalog for data, but because it contains metadata about item, okay? But one can say, okay, why do we need another catalog? Yes, fine. We know that the FAIR principle, and in particular the findability related principle, are the one that I reported in this slide. And one of them, in particular F4, is about the availability of the metadata through a searchable source. So the catalog, you see, is a kind of searchable source. So in order to enact or to have data that respond to the FAIR principle, you should have them in a searchable source. So the catalog is a way to respond to this, but not only to this specific principle, but also to the other one that are behind the findability, because the metadata that are into the catalog have a unique identifier. The metadata contains a pointer to this identifier, and the metadata can be as rich as we like, as we can see just in a couple of slides. But not only this, we also considered very important the possibility for every community to easily set up its own catalog and to build, let's say, focused view on top of catalog that exist in several repositories. So a catalog is not necessarily a way to search across a large number of repository, but should also, let's say, be a way to carefully defining the space on which the search is going to be performed. And this space might be a subset of the space that every repository that is going to be federated offer. But not only, as I said, content that exists in catalog or other data sources, but also new content that can be created by the community that is making use of the catalog. From the graphical point of view, from the end user point of view, I already clarified the fact that the catalog is not offered in isolation, but in the reality, the catalog is one of the components of a virtual research environment. So what we expect to provide a community with is not just its own catalog, but the catalog embedded in the context of a virtual research environment that is expected to support the activity of this community, to support the task this community is called to do. And okay, we already discussed about the fact that virtual research environment support co-creation, should be made available as a service. Here, I would like to stress the added value of having a catalog embedded into a virtual research environment, because this means that in addition to the basic functionality a catalog offer, like search, a way to browse, a way to apply filtered search, faceted search on top of the catalog content. There are other, let's say, side services that the VRE offer, like a social networking area or a workspace that can facilitate the development of the catalog. So for instance, if someone is willing to publish some file as a single unit, it can first collaborative work with the community and populate the workspace and create into the workspace the structure of the file to be shared. And then from that, it is easy to publish this bunch of file, organizing directory, subdirectory, and so on and so forth, as a unit of the catalog by complementing the content that have been stored into the workspace with some metadata that characterize this. And there is a complete flexibility on this side, meaning that a catalog item can be equipped with as many resources, as many payloads as needed. But not only this, the fact that the catalog is co-deployed, is offered together a social networking facility, make it possible for the community that is using the virtual research environment to comment and to collaboratively, let's say, contribute to the curation of the catalog content. So for instance, we have seen this morning about the possibility to give feedback, okay, on data set or something that have been published. Of course, this is simple in a virtual research environment because you can take the identifier of the dataset of the catalog and simply post into the social networking area of the virtual research environment. So this way, every member of the virtual research environment can participate to the dialogue, and it is possible, for instance, to comment about, the quality of the specific dataset, the fitness for purpose, any issue faced in trying to consume this specific dataset. So this, the added value of having the catalog in a virtual research environment is because you facilitate collaborative activity. You facilitate a community that is willing to make use of same services or same data. From the technical point of view, this is in a very simplistic way, the architecture of the catalog technology. The catalog that we have seen here is based on CCAN technology. CCAN is a known open source technology for developing catalog that we do extended and we do offer as a service in EOSC-Pillar. Here you see that the catalog is equipped with a number of harvesters in order to start populating its own content by reusing content that have been already published in existing repository. And here we have, let's say, both the possibility that we have seen up to now, because certainly we have developed an ad hoc harvester that collect content from, or part of the content from an instance of F2DS metadata repository, but also there are some other harvesters that are based on standard protocol like OAI PMH or CSW that can leverage on the fact that the repository natively expose their own content by using this standard. So it is easy to collect, if the community is willing to do this, it is easy to collect content directly from these data sources without the need of any mapping, if it is not needed. Apart from the harvesting, we have seen that it is possible to populate the catalog by using a graphical user interface, but also using some API for programmatic publishing content in it. And when you manage to aggregate and prepare the content of a catalog, it is very important to make available the content of this catalog not only through a graphical user interface, but also through an as large as possible set of API and standard, thus to facilitate others that are willing to play the role of service provider to count on the content of the catalog. I already, let's say, show this this morning, and I'm confident it was already shown in other presentation too. So this is the data model that is behind the catalog, and that make the catalog quite flexible for what regards the exploitation scenario he can deal with. So as you see, the catalog is, every catalog item is characterized by basic common metadata that are basic attributes that someone expects from for every, no matter the typology of item that is going to be published, like a title, a description, an identifier that is important, some tags, and so on and so forth. But also there is this notion of type, and here is where we extended CCAN technology in order to support this, because this gives the possibility to every community that is creating a catalog to augment the catalog with the possibility to create its own typology of item that are characterized in terms of additional metadata that one can specify. And we have seen how these have been used for representing, you know, training material, services, and whatever. Apart from the metadata side of the story, every catalog item contains a number of links to the actual payload, to the resources that the catalog item represent, and this can be a list of URL large as needed. You know, you see that with this mechanism is quite flexible and give the possibility to every community to customize the catalog content, thus to make it suitable for its own need. I hope that at this point, after we have seen the presentation of Baptiste and my presentation, it becomes easy to realize that F2DS toolset at the end of the story is a technology that can be instantiated, thus to provide every designated community with facility for creating its own data space, and thus every instance of these two technology together make it possible for the community to define the content that is going to be collected and made available by defining standard, by defining Adobe Harvester, and so on and so forth, whether new content can be published, and what is this new content that is going to be published, and what are the metadata that characterize the content of the specific catalog, and what are the protocol that can be used in order to collect and in order to expose the content of the specific catalog. So you see how this technology, in essence, make it possible to develop catalog that are conceived to play a role in an ecosystem of catalog. You see that by counting on the content of a catalog, it is possible for others to develop their own catalog, and so on and so forth. So building complex interaction between catalogs. Okay, I'm going to conclude with just a couple of slides. So this one somehow suggests what are the patterns that the final consumer of data can use in order to access the real payload. So of course, everything starts from a search. So a user goes to the catalog by using the user interface, or even by using some programmatic API for searching, and can search for an item. And when he manages to identify the item or the items of interest, okay, every item can be consumed by using the graphical user interface. And if the graphical user interface at the end of the story is just a splash page that contains all the metadata of the specific item, plus a number of links to the actual payload the item represents. In addition to the splash page, of course, there is a programmatic REST-based API that provides in JSON a representation of the metadata plus a number of resources that represent the payload of the item. And last but not least, of course, there is a representation in DCAT format of all the items that are into the catalog. And for all of them, there are as many distributions as are the resources that an item represents. And once you have these, I mean, as a consumer of a dataset, what you can do? Of course, you can download this payload on your own computer and crunch it locally. What you can do, you can download this content into the shared workspace of a virtual research environment. And so this means that you are sharing the content with the co-worker of the virtual research environment, and they can consume this thing together. Or you can even, you know, consume this content from the workspace or directly from the URL by using services like EOSC-Hub, RStudio, and any other service that is made available by the virtual research environment. So to conclude my presentation, I would like to stress the following point, that this is true for what regards discovery and consumption, but not only for this. And the point is that we cannot expect that there is one solution that fits for every need. So it is very important that when someone is going to offer a solution for data discovery and consumption, it takes into account, it embraces the heterogeneity that exists out of there. Not all the community are willing to use the overall global space. Not all the community are willing to search by using only the facility that are offered at the global level. So it is very important to provide specific community with a way to build their own data space and then to consume this data space in a way that is compliant with their expectation. So I hope that in this few time I managed to convince you that the tool set that have been presented by Baptiste first and by me now works together and make it possible to, you know, bring data close to each community, give in the reality, put in the reality the community of user in a sort of drive position. Okay, so that's all from my side. If there are questions, I'll be happy to reply.
Thank you, Leo, very much for this insights into the catalog component of the F2DS toolset. Do we have any questions from the audience at the moment? So there is one from Adil.
And from remote. So.
Hello, very interesting. I have a quick question. So connecting the catalog to the VRE, are you able to scale to millions and millions of files?
The catalog is not the storage of the file.
No, but your metadata, you will need metadata for individual files. So are you able to scale to millions and millions and millions of entries?
In theory, yes, because behind the scene, the technology are standard, let's say, information retrieval technology, like there is a Solar for indexing the metadata, and there is also the use of a relational database that, in theory, you know, if installed on a machine with enough computing capacity, demonstrate to work. But the point here is not to, you know, to grow inside. We are not building, you know, the Google of the data, although in theory it is possible, but we are providing every community with the mechanism to build its own subset of the overall data space and then to work on this.
No, I think, I mean, what you described is very interesting. And I think you'll find that very quickly you'll get some researchers such as Javier and others who really do have millions and millions of files that would be interested in using this. So it's not a Google, but it's individual communities that would be stressing the system quite significantly.
Yes, thank you for pointing me to Javier case, because Javier case is, let's say, behind all of what we have discussed so far, there is a point that is very important, that is about the granularity of an item. So what is an item? an item might be just one single file, an item might be a collection of files that is worth to be handled as a unit, or an item might be an entry of a long-term time series. So we should be careful, because if we start transforming, let's say, every single entry of a long-term time series as a catalog item, of course, we reach the point that you are highlighting about million and million of stuff. Okay, but I'm quite confident that people are not interested in this kind of, or at least this technology is not conceived to enact, let's say, a search at the level of a single entry of a time series.
Unfortunately, in the interest of time, I have to end this discussion here. So let's thank Leonardo again. And we move on to our next presentation, which will be given by José Dominguez from Fraunhofer IWM. And José will introduce us to boosting the findability of data, a search engine for semantic concepts. José, please.
Thank you, Philip. Well, so my presentation is about the third element of the federated fair data space that was displayed in the image at the beginning of the session. So in particular, this semantic enrichment service that was mentioned. So actually, in the title, it says it's about the search engine for semantic concepts, because it's a core component of this system that actually makes the service useful, and we will see how in the next slides. So at this point, I hope you are already familiar with what is the role of the federated fair data space in making the data more fair. Well, when it comes to describing a data set in the federated fair data space, you know that it's described with DCAT metadata, and the thing is that data sets are usually described with a title, a description, and a set of keywords, which are all strings of text. Well, we thought that we could go farther and bring also the possibility to use concepts from semantic or so-called semantic artifacts to annotate the data sets, and in this way improve their findability. So I will go in a moment into what semantic artifacts are, but let's say that the main problem with offering this feature is that there has to be an easy way to find suitable concepts to use as annotations of these data sets. So a semantic artifact is a machine-readable model of knowledge, and there are different, let's say, degrees of expressivity that semantic artifacts can have, depending on the complexity of the knowledge that you can encode into them. But more important is to think what are semantic artifacts useful for, or why do we need them? So, I mean, you have a list of bullet points there, but I want to even exemplify this with some imaginary case. So, I mean, you can imagine or try to imagine that you are a farmer. For example, you want to start a farm in France. So you have some table with, say, about pieces of land and their prices, and you, I mean, this without context is just a table, but then if you, let's say, annotated it with a concept from a legal, let's say, vocabulary that could be, for example, agricultural land, then you could immediately know that these pieces of land suit your purpose. Then also, even because some domain knowledge is encoded into the semantic artifact, you might even know that you need to pay some tax annually for this piece of land. Then also semantic artifacts allow you to specify the context in a very precise way, because as I said, for example, if you think of a forest, you would never think this is agricultural land, but because we are in a legal context, then we are precisely specifying that this is agricultural land in this context, and then therefore it follows that you could chop the trees and make a farm, for example. And finally, the semantic artifacts facilitate the interoperability when it comes to information systems, because they are machine readable, and for example, a real estate website could use this information to incorporate the listings. Well, the idea of what we wanted to do here is to offer a user experience similar to the one that is displayed on the screen. So you have a data set and you want to annotate it with some concepts from semantic artifacts. And for that, you have a search box where you can type some keywords, like, for example, tumor, and then this gives back some results. As you can see, immediately as you provide the text, you get some list of best results, and then you can select one semantic, one concept from a semantic artifact from this list. So when you click, you annotate the data set with the selected concept, and you can repeat this in a cycle until you are satisfied. Then from an engineering perspective, we had to follow a series of steps to develop this technology and integrate it with the F2DS. So maybe I will start from the end, so from the right, because I think it's easier to understand. So we want to offer the user experience that I highlighted before. So, and to integrate this into the F2DS. For that, we need to develop this search engine, which is basically a combination of two things. A so-called search index, which is a data structure made to that enables very fast access to the information, and we need a scoring mechanism to that can work on this corpus of information and sort the results. Then this index has to be built from some corpus of coherent data that is, let's say, normalized into a series of fields which have the information that we need. And in order to build this corpus, we need to harvest this information from some information source, which are actually vocabulary repositories. So within our work package, we also deployed a vocabulary repository, because we found out that in the very first step that we executed, which was this landscape analysis in which we analyzed the semantic artifacts that the EOS-Pillar use cases made use of, that was where actually our audience were not always hosted in a repository. So that's why we also even deployed our own and uploaded these artifacts. So now let's go into detail into each of the single steps that we followed. So the first one was this landscape analysis, in which we basically conducted interviews with the people from the EOS-Pillar use cases, in which they explained what semantic artifacts they were using and what were the purposes that they used them for. Then we defined some evaluation criteria with regard to whether we should include these semantic artifacts in our index or not. So the most important ones were basically the machine readability of the artifacts, whether they were already available in a repository of artifacts and their license. Then we evaluated these artifacts according to the criteria that we defined, to finally get a list of recommendations of what artifacts would be feasible to include in our search index. Well, as said, some of these artifacts were actually not available in a vocabulary repository, which let's say we needed to in order to harvest their information. So we deployed an instance of the Ontoportal software, which is a software that allows you to publish, search, and store semantic artifacts. And in that instance, we uploaded these artifacts that were not in a repository, and we have around a bit more than 60,000 concepts at the moment. Well, then after this was ready, we could focus on developing the search engine itself. So here is a summary of everything that needed to be done to, I mean, from a technical point of view, to have this. So On the right-hand side, you have, let's say, the generic ingredients that you need for to build a search engine, and on the left-hand side, you have our specific architecture. So on the top, you have actually the vocabulary repositories that we harvested. So among the ones, let's say that the use cases used were the bioportal, agroportal, and NERC vocabulary repositories, and of course the one that we deployed where we uploaded these other semantic artifacts. And the first step was usually the first step to build a search engine is to do some crawling to find what are the possible sources of information. But in our case, we predefine these sources, which are, as said, the top ones. So then the next step is harvesting the information from the sources so that we can later construct, let's say, a coherent corpus of information from them, and to later build the so-called search index, which is a data structure for very fast retrieval of information on which we can then apply ranking algorithms. So I mean, I think it's probably not yet so easy to understand because I mean, it's quite complex, but I will go into more detail immediately. So hopefully it gets better. Well, as said, we pre-selected the sources of information, and the F2DS was, again, the responsible actor here in this step. So it did two things. One of them was the fact that we registered first the repositories in there, the vocabulary repositories, and then it was also responsible for harvesting the information and saving it to a database for the next step. So the way in which you register a vocabulary repository in the F2DS is actually quite similar to the way that you register a data repository. So, I mean, you use some open API, let's say, I mean, you define the API of the repository that you are registering using the open API specification, which is a human and computer readable specification for HTTP APIs. And I mean, this usually looks like a JSON file, as you see there. But I mean, we could make use of the same GUI that was available for registering datasets. So actually, we didn't even need to do or manually create this JSON. The thing is that, I mean, after you register this and the F2DS harvests the information, then you have, you save this to a database. But since we are harvesting from repositories that not always use the same kind of software, then the schema for the concepts is different among the repositories. So the next step is to actually get this information in a coherent form. This is this normalization and curation step that comes afterwards. So here what we do is to filter first and structure the information, and also even to enforce some logical constraints to guarantee this coherence. So in this runs on a machine and saves the results to the actually the same database, where we have the concepts in the normalized form. And we didn't, let's say, arbitrarily choose this normalized form. This was actually adapted from previous work in which actually Jan participated. And the most we try to capture the important details for our use case. So the unique identifier of the concept, the label, the description, the synonyms of this concept, and also similar information about the semantic artifact in which the concept lives in. So once we had this information, then everything was ready to build the search index. I mean, why do we, for this, we use say, a tool called Elasticsearch, which is a sort of framework to build search indexes and search engines. And then we made this we choose this because it offered us a simple way to build the search index, which, as said many times already, it's a data structure for very fast retrieval of information. So this is even better than the database itself. That's why we're using it. And it can also work on distributed architecture, so using several machines. Actually, we are using 3 machines for the index to get the response times that we want. Yeah, actually, if you add some water, it will help. But yeah, and then it also offers a, thank you, a query language that can be used to select the fields in which we want to search. And it also has built-in scoring algorithms that with which you can give the importance that you want to each of the fields of the schema that we highlighted before. And yeah, so fortunately we are at the end of the presentation because seems I have some trouble, but yeah, I mean, now the next presentation is actually a demonstration of all these concepts that we have shown in the session. And there you will see how this search engine is integrated into the F2DS in 2 ways. So one of them is to, it lets, it takes the data sets and the keywords that they have as metadata defined, and it looks up these keywords in the index when you publish in the engine when you publish a data set. So it kind of semi-automatically annotates already the concepts, and then you can fine-tune what the F2DS did automatically. So discard a concept or even add more, or you can even search for your own, write your own text, as was actually the desired user experience, and add more annotations if you desire. So thank you for your attention, and that was all from my side. Yeah, and of course, if you have questions, please go ahead.
Yeah, we have time for questions if there are any from the audience or from online. None online. So do we have questions from the audience? So, I will ask one. So I'm a bit curious about the performance that you mentioned. So have you measured the turnaround time for retrieving concepts when you type?
Yeah, I didn't measure that. So I mean, maybe you have some information. I mean, I actually, I mean, I didn't measure it in the final state, but I at some point I used I mean, when it was in development, I used the development tools of Elasticsearch, and actually it tells you what's the time it takes to search for something in the index, and it was in the order of milliseconds. But it's also true, I mean, sort of like 200, 300. But it's also true that at that point we didn't have the whole corpus. I mean, around 15 million concepts in the index. So maybe it was, I mean, it could be a bit slower, but I wouldn't expect it to be much more. I mean, that's the response time of the index itself. There is a round trip time between you on your computer and the server, you know, which adds a bit more latency, but under a second is the expected time.
Okay, thank you. Jan has a question now.
I have a question. I don't know if you can hear me.
Mm-hmm.
How long did it take to build that index with 15 million concepts?
Yeah, I mean, for the it actually doesn't take that long. I mean, I asked Alexandro, which was a partner, which was actually doing the Elasticsearch task, and if I remember right, it was under half an hour, right, Baptiste? I think he said. So it was actually quite fast. I was also surprised that Elasticsearch is even that good at building the index itself. Yeah.
So would it be possible to now add more resources on the fly to the index?
I would say so, but
scrolling over the index?
I mean, I even will, let's say, talk bad about what we did, but I think if we really want to do that in a really massive scale, like, I don't know, 100 million or whatever, then we should design some systems so that we only, because right now when we build a new index, we are ingesting, let's say, the whole information again. And we should build something that actually only ingests the new information, so that, you know, as the whole system grows, you don't need to repeat useless steps, and then it can actually scale in a proper way.
Thanks.
Do we have further questions? If it's not the case, then let's thank the speaker again.
Thank you. I sit there, right?
Yeah, well, you sit or stay, and I call Marwa Salem to stage, who will guide us through the demo that we have prepared for today. We made up a little story for this demo. We have an introductory slide, I think. It's at the end of it should be. Sorry, this one end of José's slides. Let me just close this. Sorry, Rob. Can you put on José's slide again? Because there's something dangling there. Okay. Oh, it's not there. Oh, sorry. I have to. Where's it? Oh, yeah. Okay. Now it's. Let me just make sure. So it's a demo from the whole work package 5 team, combined with a use case. And the story that we, how should I say, that the story that we're telling is that so we have a scientist who is compiling a data set for her team. The team is working on somatic variant calling. So I think Marwa will explain us what it is. And so during the compilation of this data set, she enriches a catalog item with semantic concepts from the ontologies. And second part is Baptiste, who is in this team responsible for the quality assurance. With this function, he requires minimum fairness to the data. He will check it and show us how this can be performed in a VRE context. And finally, José will show us how we can make use of these concepts that have been then connected to the data set to get context information. So
this is my I need it. Yes.
So everything is live. As you know, live demos are always bumpy. Let's see how it goes.
Yes. Okay. Yeah, no, I will start by introduction on data set. Okay, look for Thematic. Starting from the beginning. No. No, it's not. Okay. So I will tell you the story like this. So I am an INSERM researcher. So my job is like to publish my data sets on the INSERM repository. So that's what I did. My data set is named Semantic Variant Calling. It's a powerful tool that we use to analyze the cancer studies. So my data set is like composed by 4 files. 2, they represent the normal patient's tissue, and the other 2 is the the same patient tumor tissues. The aim is to compare these 4 files. So as a lazy researcher, but I couldn't show you for some reason, I published my data sets on the INSERM repository with only 1 keyword. And then I joined the EOSC-Pillar project. So I heard about F2DS and I said, why not use this opportunity? So now it's like, I'm gonna use the service of the F2DS. I'm gonna go. You registered or not? See, yes, it's yeah. Yeah. Okay, I'm gonna log in. I think it's not the same. Why I don't have the same one like you? Oh, sorry, I'm using Baptiste account. Okay, cool. Okay, thank you. Yes. So here's like, I will start by, as Baptiste, he explained on the F2DS steps, different steps. The first one is to register my dataverse. So here is like, I will create the dataverse. I will name it demo, live demo. It's easy. I can give description, but it's okay, you can give. And here is like, I have to inform the URL of the original repository. So here I will inform the URL. Okay. And then I will publish my catalog description. I was able to create the repository, and in this step, I must inform and register the API that I am going to use to fetch for to harvest my original data set. Here I will work on live demo. I go to the part where I have to inform and to register my API. So I will import, since it's live demo and we have not enough time, so I will use the register. And final event. Last one. Okay. So open. Okay. Yes. Okay. Open API. Okay. I did import the different information about my API. So I go to next. Here is like everything is okay. I go to the next step. Okay, I got the DOI of my data set. Next, the next part is to map my to ensure the mapping of my metadata. So I need to select one ontology. Here I will use the DCAT ontology. Okay, normally this is the part where we said like manually we have to fill some different fields for my metadata, and once we filled the first time, we can save our JSON file. So this is what I did before. So, and that is, so I will import the DCAT mapping file. And save. It's the same thing like last time. No, it's okay. Okay, so I would, yeah. I do always want. I forget. I'm sorry, but I forgot. We need to check this option. So here we will check our mapping. No. Let me check. Okay, here I can check whether my mapping it was good or not. So we have the different field, the title of the data set, the description that I gave them the original repository, who did create these data sets and everything, the name and everything. So once I make sure everything is okay, so I validate this part. So I go to the next step, which is the semantic enrichment. Here I have one keyword, so this is what I basically from starting what I mentioned, so semantic mutation. So in this part, I will add some semantic ontology. So for example, I will add tumor tissues. Okay, the first one, it gives me the definition, whether I am okay or not. I can check or uncheck this box and tell like if it can represent, this ontology can represent my data set or not. So here everything is okay for me. So I will publish it. And now I have my data set, the enrichment of my metadata with one extra semantic ontology. Okay. If I refresh, and here I go to home. So I go to live demo test, and my somatic variant calling in keywords, I see like tumor tissue, it was added, but also it was added as semantic ontology, not only as keyword. So as Baptiste said, I must go to the F2DS catalog. Okay, and here I must find.
It's just to show
the
result of the publishing.
Yeah. I have to find now my demo INSARM is here. So here I can find my somatic variant calling with the different theme taxonomy and the different keywords. This part of my demo is finished. I don't think that Leonardo, he will publish it manually now on the G4 Science. So normally after this one, we have to wait 24 hours and then our data set, and it will be published in the catalog of G4 Science.
Yes, it's harvested nightly to the VRE.
So I leave the stage to Baptiste so he can present.
So my role is to check the fairness of the data sets. So to do that, I'm going to use the VRE. So through the VRE, I have an access to the Fuji tool. Fuji is a tool developed during the Paris Fair project, and is using metrics to evaluate the fairness of data sets. So just copy the link to the data set. And let's see if the fairness evaluation is okay. So it's not okay because I will not. Ah, yes, sure. So yes, it's much better because we have a result of 50%. And so it's a pretty good result. So I think we can compare with the initial data set. If I can find it. Okay. So we have 29%. So we have the fairness is we have an improvement of the fairness of the data set. So it's good. So then gives floor to Jose for his role.
So what I want to show you essentially, it's what context do we gain from the semantic annotation. So also because it's not, sometimes I see that it's not easy to understand what do you want this for. So maybe the best way to actually see this is to use so I mean, what you are seeing here is actually, because we actually didn't work yet on the feature of showing the label of the concept that we put the annotation with, but you see the unique identifier of a concept, which is actually a normal URL that like the ones you use on the internet. So if you actually click on it, you are most times redirected to an actual page that immediately shows you the additional context that you gain from it in a nice, let's say, in a human readable way. In sometimes there is even an endpoint for machines. And in this case, we followed one of the annotations that actually this one's one of the automatically added ones, the semantic mutation. And in there, you immediately have a definition of what this is. Even if there were synonyms, this is a longer explanation of what this is about that is more precise, and some related concepts. And even I think for this use case, the most interesting information is the fact that, as I said, semantic artifacts have domain knowledge embedded in them. And in this case, you have what diseases are associated with somatic mutations, sorry. So you have here a long list of them and the, let's say, gene associations. Even then you can follow a specific disease that is associated with this kind of mutation. And you have, as usual, the description and even the terms it's associated with. And in addition, another domain, let's say, knowledge that you have embedded in this annotation is the fact that this somatic mutation belongs to a hierarchy of concepts. Actually, it is a mode of inheritance of genetic traits, or actually, in this specific case, is a non-inheritance. If I remember, yes. So I mean, these are the kinds of mutations that are not hereditary, but nevertheless, it's classified in this category of terms. And yes, so this is what I wanted to show you with regard to the annotations. So, and we are also at the end of the demonstration. Thank you.
Yeah, great. Thanks for the team to have the courage to take this as a real live demo. Do we have any questions from the audience? Okay, there's one from Adil.
It was very, very interesting. One question I have, so you did a lot of work to define these terms for the data set. So this is sort of intellectual property. Is there a way to issue a DOI for that, or in order so that you can get credit for it? Because you've done the work, and if I came along later, I just look at your data set and say, oh, she defined these terms, I'll copy the same thing. So.
I don't know, but isn't it the aim of this work is to make the data set open? So I don't think in terms of keywords and everything that intellectual property is that much significant, since it's only some keywords that does describe some data set. So maybe if I've never seen like some researcher, they are opposing for the fact that some other people, they annotate their data set using the same keywords. After all, it's the same domain that we are using the same keywords.
I mean, the thing I'm trying to get across is that you're enriching the data. So
Yeah.
you're using your own knowledge of the domain to provide additional information, and it's important that that's somehow recognized.
Yeah, maybe. I don't see some technical, how technically we can recognize this too.
So
Yeah.
that makes sense. So in terms of IP here, you're just talking about the fact that you're adding more keywords to the data set.
Yeah.
So here there are two different aspects. One is there are keywords that have been provided by the person who published the data set, and you would like to align them with existing ontologies, which is some extra work, but it's semi-automatic. So I don't think that you should have credit for that. You still can, but I agree. The other is when you enrich and start adding more keywords to actually make it more searchable. In that case, well, we haven't considered that in this use case right now, but then you could use annotation services like we used to have B2 Note from UDAT that actually aggregates and allow you to annotate these data sets, and then you can package them and you could get a DOI. Here you cannot really get a DOI because, well, it's just like you add a URL to the keyword field in the metadata element, right? So there's no provenance information on that. So, but indeed, that would be nice to enrich that if you want to do extra annotations with a dedicated model so that you can get the provenance, and then you can publish that so that you can indeed get a DOI.
Okay, thank you, Jan. Inge has one comment, question.
I don't know if you will answer it or maybe Jan can answer. It's about the connection to the interoperability framework and the onboarding of EOSC that is being worked on now in the working groups of the EOSC association, for example. In how far does it, what do you see in the developments there? In how far are we connecting to what's happening there? Is this feeding back into the discussion on the interoperability framework for EOSC? Is it would it be something like this? Because with my question at the beginning, with this step in between that you can that you can map your repository to DCAT and then go a step further. Will this be also an option in like the interoperability framework? Do you have an idea? You don't know? Okay, that's what popped into my mind.
So Jan, use the microphone and please be short.
Yeah, sorry. So we have no contact with the people working on the EOSC interoperability framework. And there are two different approaches. There's the former one that was led by Oscar Corcho with the, I don't remember the name of that small project, the EOSC Secretariat, I think, where they had the task forces. And there is EOSC-hub, EOSC Future, who is also working on the interoperability framework. Thing is, I'm not sure that EOSC Future is aware of this work. So we need to do some communication with them and tell them. However, it does implement some of the vision of the initial interoperability framework, because in this interoperability framework, it's been clearly said that we need to get ontologies into dedicated repo. And so what we did here is just use the F2DS to collect the ontologies so that you can have another service, which is the index, that gives you fast access on distributed ontology repository. So it makes the point of we really need that, because actually it's done automatically.
Okay, thanks a lot. So before giving the last word to Rob for the housekeeping notes, I would like to thank all speakers of the session again.
Thank you. So now we'll go into coffee break. Yeah, but we have to be back on time at 4 p.m. Just aside from this, I would like to add a little note. So initially we were planning to have an EOSC-Pillar Consortium dinner tonight, but actually we would like to extend this invitation to everyone who is attending here today. We'll provide you with information on the exact location later at the end of the event. So please join us. It's at 7:30.
By the association. Enable seamless access to data through interoperable services that address the entire research data life cycle, from discovery to storage, management, analysis, and reuse across borders and scientific disciplines. Currently, more than 200 institutions spanning over 27 countries are members or observers of the EOSC Association. EOSC aims to make it easier to find, access, and reuse research data, tools and services by connecting digital infrastructures to provide seamless access to research data and services for the scientific community. This goal will ultimately be achieved by providing an environment where European researchers from different scientific disciplines and countries can work together more efficiently. This web of research data and services will make research more innovative and impactful. This rich ecosystem is being implemented through several projects funded by the European Commission, which work together for the common goal of getting EOSC ready to foster fairness of data and services. Possible tools to connect to EOSC are accessible through the EOSC portal, where providers can register their resources into the EOSC portal catalog. These resources are then made available to prospective users through the EOSC marketplace, where researchers can find resources suitable for their needs. EOSC will have a different value for different actors. EOSC will offer to providers, infrastructures, and researchers the framework and tools to enable sharing, discovering, and accessing the resources in the research ecosystem. Resources can be composed to provide new added value services. A good example of this is the COVID-19 activity, where specific services allowed daily epidemiological data to be made available to all scientists for multiple analyses. As a further step, EOSC core services will allow their integration into automatic analysis pipelines to feed predictive models of major importance for governments to assess the impact of public health interventions. For researchers, the main benefit will be the possibility to find resources suitable for their research activity and combine them with resources delivered by different resource providers. For service providers, the main values will be the possibility to increase the visibility of their services or resources and to more easily allow for their composability with other services, thanks to the EOSC interoperability framework. The benefit of joining the EOSC development for e-infrastructures and research infrastructures is triple. It is the possibility to, firstly, to increase the visibility and usability of the services provided by the infrastructure. Research is about providing and sharing results, demonstrating ability to offer services at the European scale. Secondly, being part of the EOSC landscape is an important aspect to receive future funding, both from the European Commission and on the national, regional, or institutional level. Many roadmaps and policies already give EOSC as one of their objectives, and this trend is going to increase in the upcoming years. Thirdly, improve their activities by leveraging skills and expertise beyond their community. The EOSC community is a strong network of knowledge, and the Commission finances EOSC-related development in infrastructures. The rich EOSC environment is continuously growing, as new service providers and resources are joining the EOSC portal. As of May 2022, there are more than 200 service providers, making more than 300 resources available through the EOSC portal marketplace. EOSC-Pillar helped the agri-food community to leverage existing infrastructures, data resources and services to optimize its workflows. The EOSC-Pillar use case 6.3 is based on an institutional data repository, Data INRAE, and illustrates how we can defragmentate such data repositories, thanks to their integration with the services and resources for the European Open Science Cloud. Using the Galaxy platform, made available through EOSC-Pillar Use Case 6.6, contributed to build an integrated and interoperable service for Elixir. All this work contributes to encouraging the adoption of fair data principles in health sciences. It is also demonstrating the added value of the European Open Science Cloud through federated services and common best practices. EOSC will have a value for you. Through the catalog and marketplace of EOSC portal, you can connect and experience it. Enjoy the EOSC ecosystem.
We organized this workshop about national policies, started from EOSC Synergy project with the collaboration of other regional projects. All these projects are reaching the end of their life, and so we have results that we wanted to share with the community.
The session we just ended was on open science and EOSC policies and their counterpart at the national level, and we also spoke about the harmonization.
They have been chairing a session on funding policies. The purpose of the session was really to understand and discuss the work that the regional projects did in their countries and regions about funding policies.
What the session was about access policies and what the experience from the regional projects was, really the practical advice what we have to improve in order to give access transnational, for example, to services and data.
EOSC-Pillar presented two important outcomes, guidelines for harmonized open science policy at national level and overcome some problems on IPR and protection of personal and personal data, and the methodology that has been developed for creating business model for the EOSC services.
So we have to find ways to make policies that are national come together. We have to find ways to have legal regulation that is national come together, and we have to find a way to leverage national funding so that we can build something that is bigger than the sum of the parts, that serves all of Europe, but is nationally owned and nationally funded.
NIFOS Europe supports the establishment of national open science initiatives in 15 member states and associated countries. The regional project model has tangible results in EOSC governance in this region and should continue. EOSC stakeholders should translate to a proper business model. The motto, free at the point of use, does not mean free at the point, free of charge. And we ran an open call for providing access to our thematic services, generic services, and repositories to the broad pan-European research community in order to test the services, engage scientists in open science, and contribute in EOSC capacity building.
The social element of this first big conference after COVID was very good. It's nice for the community. I think overall my impression was the atmosphere was very constructive, very positive. Everybody trying to look forward aligned. And when I say everybody, I mean the projects, the 5B projects, I mean EOSC Future, I mean the EOSC Association representatives that are here, I mean the EOSC Steering Board representatives that are here, and even the Commission who also participated in the event.
This is Anne. Anne has created a service for the Earth Environment Sciences and Geosciences communities in France. Her service allows scientists to easily access different data sources, including data from satellite, in situ observations and climate models, which are usually managed and preserved separately in domain-independent repositories. Anne wants to enlarge her user base, so she wants to make her service available in the European Open Science Cloud, an initiative by the European Commission which fosters sharing of services and data among the scientific community, as well as other open science practices. Through the EOSC portal, Anne learns that EOSC offers several core services, including federated authentication and authorization infrastructures, AI. Integrating her service with Federated AI will allow her service to reach international users from different scientific communities, enabling them to use their existing federated credentials. The Indigo Identity and Access Management IAM service, one of the EOSC Federated AI solutions, features a simple design, uses open standards such as OpenID Connect, is flexible to different use cases, and auditable. Anne gets in touch with Pietro, an expert on the Indigo IAM service. With the guidelines provided by the EOSC-Pillar project and Pietro's help, Anne is able to integrate a federated AI into her service with a few clicks. In Indigo IAM, at the operational level, different roles, such as admins and standard users with different access privileges, can be defined. Now scientists from different communities and from all over the world can access Anne's service without registration. For example, Ursula, a scientist from the German research community and from another institution, can log into Anne's service. Moreover, scientists can seamlessly use different EOSC services at the same time with a single sign-on. For more information, visit EOSC-Pillar.eu.
On the technical side in the project, 2021 has seen the first release of the Federated Fair Data Space, which provides a framework for aggregating metadata from heterogeneous and distributed data repositories and align the metadata of these repositories with the DCAT model to publish them in the end into an instance of the Fair Data Point reference implementation that has been developed with one of our collaborating projects, the Fair is Fair project. The Fair Data Point constitute a centralized and harmonized metadata catalog and contribute to the improvement of the verification of the different repositories within the project without requiring any change. This first version of the Federated Fair Data Space has been delivered in September 2021 and is currently being extensively tested by the different use cases in the project to enrich and transform their metadata content. After designing the index of ontological concepts, we are currently implementing a first version to integrate this index into our Federated Fair Data Space to allow the enrichment of metadata with ontological material. We are continuously improving the federated fair data space with the feedback from the different communities and testers. We also continue to work on aligning and providing services and infrastructure support for the community demonstrator within the projects. We worked on establishing guidelines for integrating some of these services into EOSC. We are aiming to provide a finalized version with registered data repositories from the different communities. We are also expecting to have integrated previously unconnected service into the EOSC ecosystem. We will provide a proof of concept of a multidisciplinary search engine to find concepts from semantic artifacts that is built upon relevant community resources. We will also release an Ontoportal instance that will store all the semantic artifacts from the communities in Pillar that were not easily accessible. We will provide a set of services that are integrated with Common AI, and we will provide an extended set of ready-to-use infrastructure services, such as the D4Science virtual research environment, dedicated and improved Galaxy workflow services, and more.
La fairisation des données, qui, si je me rappelle, signifie findable, accessible, interoperable et reusable. Ça a un impact tout à fait positif, ne serait-ce que pour créer des outils à destination de la recherche, mais aussi des outils pour les étudiants.
J'ai créé avec des collègues une base de données bilingue avec des textes en langue amérindienne, de l'époque coloniale jusqu'au début de l'époque républicaine. On a réussi notre pari, à savoir de faire une base de données utilisable par des personnes qui ne sont pas dans le noyau qui a créé cette base.
C'est exactement le rôle de ce bibliothécaire du temps de ma thèse qui allait voir le chercheur et qui lui disait « s'il vous plaît, ramenez les livres pour que tout le monde puisse les utiliser ». Donc le premier impact pour moi, c'est celui-là, c'est d'amener les collègues à partager.
J'ai commencé à mettre la version PDF sur HAL, ne serait-ce que pour le signalement, mais aussi pour la récupération des données elles-mêmes. Mais c'est vrai que pour les collègues dans le domaine de l'histoire littéraire, ce qui compte, c'est l'édition papier.
Nous sommes dans un lieu où parfois encore il y a une forme de personnalisation qui peut être assez aiguë de résultats que l'on a acquis et que l'on n'a pas envie de partager trop vite.
Ce qu'il faut comprendre, c'est que par le partage de données, quand c'est bien déposé, que les métadonnées sont bien enregistrées, etc., nous, en tant que créateurs de la donnée, on n'est pas effacés. Au contraire, notre présence, elle est affirmée.
Dire qu'on a travaillé sur des données qui sont inaccessibles, ça veut dire qu'on n'a pas travaillé. Vraiment, l'exigence chez nous de reproductibilité en maths et en stats et en informatique, elle prend des proportions très importantes.
Il y a ce paradoxe, il y a ce double tranchant, d'un côté d'une nécessité d'ouverture et puis d'autre côté, attention, vie privée.
Si on garde les données pour nous, en fait, il ne se passera pas grand-chose. Le fait de rendre tout de suite les textes accessibles, cela a encouragé nos collègues historiens de nous envoyer leurs textes, donc d'enrichir notre base. Nous, on leur traduisait et on le mettait en ligne. Du coup, c'était d'emblée partagé.
Tout le monde refait tout le temps le même travail parce que c'est pas fait de la même manière et surtout parce qu'on ne sait pas de quelle manière c'est fait.
Tout l'enjeu en fait pour les arts de la scène, c'est de définir ces champs de description pour ensuite pouvoir exploiter cette information sur le plan scientifique.
Comment on repense les corpus que l'on fait? Qu'est-ce que d'autres vont pouvoir faire avec mes données? Et donc, les préparer d'une certaine manière.
On a dû se mettre d'accord sur un certain nombre de données que nous voulions voir dans cette base de texte. Il a fallu aussi se mettre d'accord sur ce qu'on appelle les métadonnées, c'est-à-dire les éléments qui permettent de décrire les textes que nous mettons dans la base de données.
Plus on va donner d'éléments de contexte, plus on va donner des éléments pour comprendre comment ces données ont été construites, plus, à mon sens, elles vont être réappropriables.
Je ne me fais pas trop de soucis sur la pérennité des données. On réfléchit à ça. On a le PDF Archival qui est complètement stable. On a le PET format CSV qui est increvable.
Les SHS, c'est plus problématique parce que les données ont besoin de plus de contextualisation. Il y a des questions d'homogénéité dans le temps, dans l'espace, notamment lorsqu'on travaille sur des données dans le temps long.
On a une masse de textes. Je crois que si on réfléchit dans la perspective faire, on peut négocier à commencer par certains textes, à continuer avec d'autres. Et cela nous amènera plus rapidement, collectivement, à cet objectif d'une bibliothèque qui serait requêtable par tous, qui serait exploitable par tous.
Il y a d'autres aspects qui sont ceux du danger d'une forme de standardisation trop prononcée qui, justement, tendrait à ne recourir qu'à des métriques, qu'à des formes d'indexation strictement quantitatives ou strictement logiques, en négligeant l'ensemble de ce qui est qualitatif, qui est une part irréductible des données en sciences humaines en général et en écologie en particulier.
S'il y a des règles, des standards sur les contenus, il n'y en a pas sur la façon dont on les traite ou comment on arrive à faire ce qu'on fait aux données. Donc il y a toute une partie de notre travail qui mérite d'être observée, décrite et formalisée.
C'est-à-dire quand on écrit, quand on collecte des données, d'avoir un protocole de recherche explicite, écrit et compréhensible.
Il y avait un devoir de trouver le moyen de pouvoir diffuser des connaissances très brutes, très liées au travail, pour en faire des synthèses. Ça me semble extrêmement important, que les données deviennent simplifiées, transformées, accessibles.
On va véritablement moins surreprésenter le travail de recherche comme une quête solitaire d'une vérité plus ou moins saisissable, pour beaucoup plus un travail collectif.
On a mobilisé les compétences d'historiens, de philologues, linguistes et d'anthropologues. Un projet de base de données de cette ampleur-là ne peut pas se faire sans une équipe pluridisciplinaire. Et c'est justement parce qu'elle est pluridisciplinaire que la donnée est la plus partagée d'une certaine manière et qu'elle devient la plus interopérable possible.
Je pense que la férisation des données, ça va contribuer aussi à rendre réutilisables nos données et à les rendre visibles.
D'une manière générale, partager les données est devenu quand même, surtout pour les jeunes générations de chercheurs, une priorité, une prise de conscience.
Je pense qu'il faut continuer à organiser des stages, à organiser des rencontres au niveau pas seulement européen, mais international.
Donc je pense que c'est une forte opportunité pour se pencher vers des directions nouvelles. Et ça donne envie, en fait. Voilà.
Pour moi, une donnée dans mon champ de compétences, c'est tout d'abord un document qui est issu des arts de la scène. Donc ça peut être tout type de document.
Mic test. Hello, hello. Hello, hello.
So we are going to start this final session of the day with two sessions. Yeah, second to final. And so we will speak about the supporting national actors to join EOSC, and this session is about the achievements of WP7 work package. So I'd like to introduce, for those of you who don't know them, so Geneviève Romier from CNRS, okay, Luciano Guido from INFN, and then Lisana Berberi from KIT. And so I will give the floor to Geneviève, who will give the first of the 3 talks of the session.
Good afternoon. So I'm going to present supporting national actors to join EOSC. My presentation will begin with an overview. Next, I'm going to explain our goals. Then what are the services we provided with support, and give various examples of achievements thanks to EOSC-Pillar and finish with some recommendations to achieve a high level of quality. WP7 is the infrastructure layer. That means delivering horizontal data storage and computing services from national to transnational activity. It is about to bring together user communities, use cases, infrastructures, and service providers. For that, we provided technical support, strategic guidance for the integration and federation of services in the EOSC ecosystem. That means how to join EOSC. Here you can see a schema that is an overview of what we did, of the actions we conducted inside WP7 and outside in the framework of EOSC-Pillar and also in EOSC at large, and with a consideration of external potential users or providers. In green, the green frame, you can see WP7 and the 4 tasks and the interactions between the tasks. They will be detailed later. We had also strong interactions and collaborations with other work packages, especially WP3 about the contacts of the survey, of the national survey, with WP4 about the catalogs. You have heard a lot about that before, with F2DS in WP5, with the use cases, WP6, and of course, with WP2, it's not in the schema, but we had also collaboration. And with other projects, other EOSC projects and regional projects. There are only 3 logos that are those of projects that we strongly collaborated with, but we also collaborated with the others, but the picture is not big enough to put all the logos. And we had also collaboration with EOSC institution in EOSC entities, such as the EOSC Association, and so on. We also provided videos, documentation, recommendations that are available for everyone in the world that is interested. Here is a sort of summary of the picture I explained quickly. So this is all about relationship and collaboration in order to reduce fragmentation and avoid silos. So our strong collaborations have all the objective to help every service, every user to join EOSC and to have the same objective, the same actions, similar actions with other projects, and to join our resources, our ideas. What are the services we provided with support? Here is the list. It's a long list. You see that there are different categories. First of all, the ready-to-use services. That means the services that were a part of the proposal. And you may recognize here Galaxy, Laniakea, virtual laboratories and virtual research environments, and so on. You have another category that is ready-to-use services provided as in-kind by the partners. It's a little bit different because they are provided as is. You have the first one, Indigo AAM. I think you know it very well, and others probably less known but useful too. The third category are the services coming from the WP6 call that Lizana explained in a former presentation. We have also F2DS that comes from WP5. And also, of course, services provided by the WP6 use case. I hope I didn't forget one. The most common achievements that are made thanks to EOSC-Pillar are the registration in the EOSC catalog and marketplace, the adoption of a federated AI, service quality improvements, and user expansion. That means a better adaptation to EOSC. Here are now various examples of other achievements that are perhaps just for one or two services, but that are interested. For example, the first one, the use of acceleration resources, the service about GPU. They wrote many documentations, then they translated them in English. They are now available publicly. They set up policies and an operation manual. For Laniakia at RECAS, I just wanted to point that their example is about best practices that they followed on a basis they decided with subtask 6.6.1, and also another best practice is to follow the project, the Galaxy project Ansible rules to allow a faster alignment of their Laniakia flavors to the latest Galaxy releases. Another contribution is a contribution to Galaxy E, that is Galaxy for ecology, and they developed a scientific workflow dedicated to ecology in Galaxy, and they made a tutorial and dissemination of their results in conferences. Other various examples, 12 virtual research environments have been created in the virtual laboratories VRE, and that means more than 500 new registered users. And we all had the opportunity to play with during a face-to-face meeting. I don't know if you remember, but it was really interesting. And they made also various publications. PICO2 is more on technical part. They managed to launch a distributed memory program that is a specific program for HPC clusters from a Galaxy server that is not HPC and without writing a script in OAR. And they manage also to have seamless communication between data and calculation through a connection between Dataverse and a VM, a virtual machine deployed on an HPC center. Other examples are for OI and marketplace projects, a connection to Dataverse, the integration to an AI, and they noted that the maturity assessment help them to have a better view of their priorities for requirements. For real metrics, this is a sandbox they set up in EOSC for institutions to test the service without a lot of work. That means without having to install it locally. And they also integrate Indigo AAM. That are only examples. It's not exhaustive. And if you want to know more about that, you will be able soon to read the other examples in the Deliver Update 7.4. I would like to finish with some recommendations for high-level quality and mature enough services in EOSC infrastructure level. About best practices, we recommend you to follow the guidelines and documentation that we produced in WP7, and you will have details in Luciano and Lisana talks. About method and tools, we recommend to adopt the maturity model assessment we set up in WP7 to improve the quality of the services, and you will have details in Lisana's talk. Federation building components. We recommend to use a single sign-on service through a federated AAI, and you will have details in Luciano's talk. And about competencies building, we noticed a gap between people that have technical background and people with scientific background. And we recommend to complete your staff with people that are skilled in both domains, technical and scientific. And I would like to say that what I presented is a work of all WP7 and not my own work. So I'm really proud to show you what WP7 did in EOSC-Pillar. Thank you. If you have questions just on this presentation, you may ask them, but I propose, if you want details, to ask questions after the next presentations. And stay tuned.
Okay, so I think we'll take questions at the end, and so now I invite Luciano. Yeah, thanks. So, now I will talk a bit about what we did for the support of the user communities and the service provider in EOSC-Pillar to connect with the EOSC. So I will explain the approach we adopted, and then I would talk about the EOSC catalog ecosystem and all the related stuff to be part of this ecosystem, including the model for a national catalog developed within EOSC-Pillar, the activities around the catalog's interoperability, the document we prepared to explain how to operate an interoperating national or thematic catalog, including the onboarding agreement among the catalog owners or operators. I will talk a bit about what is needed when onboarding a service or a service provider into a catalog. And then I will show you briefly what is the documentation we delivered and the other materials. And then I will give you some hints, some conclusions. So the approach. The main concept is that it's all about connecting various things. So the users are at the center of the story and the driving force for our activities. Because in Europe, in the research environment, there are silos and fragmentations. And so the EOSC aims at closing the gaps and reducing the fragmentation at different levels. Fragmentation among activities, services, and people. And this has been addressed in various ways. On a very technical level concerning the services, the EOSC portal providing two services, a catalog and a marketplace, has been developed
centrally by EOSC Enhance, EOSC Future, EOSC-hub, and then EOSC Future. But there are a lot of other catalogs part of this ecosystem. And this is important only if these different instances of catalogs are made interoperable. So the first step is connecting the actors, which means the stakeholders, the various types of stakeholders, research communities, service and result providers, institution, and of course also the EOSC Association, then the policymakers and the funding agencies. So for this, the engagement activities at all levels are paramount, but you have already heard about this by Rob yesterday. The next step is connecting activities. So there are so many EOSC-related projects funded by the European Commission and also at national level. And there are various places where the connection between these activities can be exploited. Several things I've already mentioned in the previous days, in the previous presentation. The collaboration, the cooperation among the regional projects through which the activities have been carried out jointly, or the issues studied through the task forces. And for the activities I am describing in this presentation, the service onboarding task force is the main important one. Then also at the EOSC Association level, there is an important task force, the Rules of Participation and Compliance Monitoring Task Force. And of course, the flagship project are important for the regional project. The cooperation with the EOSC-hub project the last years, and then now with the EOSC Future project is very important. So in order to go on with practical support for the user communities and the service provider, this picture has been developed to represent the ecosystem where there are a lot of different catalogs. The central one on the right, and the other catalogs, thematic or community catalogs on the left. If you can see that they are connected, so the providers can onboard a service either to the central catalog, to the EOSC catalog through the EOSC portal, or to any EOSC recognized catalog. And it is the same because if they are made interoperable, the information, the resources onboarded into one of the catalogs can be transferred automatically and in a transparent way from one catalog to another. So it is all these catalogs are available for the user communities, which have to find the services suitable for their needs. So one of the activities around catalogs in EOSC-Pillar was the development of a model for a national catalog. Leonardo has already explained the features of this catalog. It is based on the profiles developed at the EOSC portal, and this makes the interoperability between this model of catalog with the EOSC portal one very simple. This catalog has been implemented as a proof of concept for the Italian community, but Leonardo has already explained this. For the interoperability among catalogs, this was started with the EOSC-hub and EOSC-Enhance projects. Now the catalog is operated by the EOSC Future project, and the contribution to this activity by the regional project has been very important in order to define the policies for the implementation of this interoperability. So the requirements have been collected through several lines, including the regional project onboarding task force, which was initially led by NIFOS and then by EOSC-Pillar, and also through a new board a new group, the EOSC Onboarding Strategy Group, and we as a EOSC-Pillar project are contributing to this. It is very important because information and requirements have to be collected by a wide range of actors in order to be sure that all the needs spread all over Europe in the different projects, the different user communities are collected properly. So, what has to be done to operate a catalog which has to be made interoperable with the EOS portal? There are a number of things to be done to ensure this interconnection. And for this, we delivered a document with a sort of checklist, a number of steps to be followed to grant this interoperability. So the document has been released. You can find the link here. And in my opinion, this is very important for everyone willing to operate a catalog. This is one of the steps, one of the information needed for this. But this is not enough. It is important that both catalogs interoperating have an agreement describing what are the features of the catalogs, what has to be done at the various catalogs, and what are the mutual commitments for operating the catalog. So this document has been prepared by the EOSC Onboarding Strategy team, collecting information from a wide range of actors. Then it has been approved within the EOS Future project by the Technical Coordination Board. And now it is cast in stone. It may possibly evolve in the future if needed, but now we have a working document for this, and the link is in the slide. When a service provider wants to onboard itself into the catalog and then onboard the resources, what has to be done? The catalog operators have to ensure that the information in the application is complete and correct. And then they have to assess if the information is compliant with the inclusion criteria, which are derived from the rules of participation. As you probably know, the rules of participation have been defined by a specific task force of the EOSC governance, the initial governance of the EOSC. There is a document published about this. But with the advent of the EOSC Association, a new task force has been created, which is in charge of revising the rules of participation in order to be more inclusive and possibly more transparent. Then after these new, the rules of participation will be updated, it is important that the inclusion criteria adopted by each catalog follow the evolution of these rules of participation. So this activity of assessing the compliance to the inclusion criteria should be done when the service provider and the resources are onboarded, but then they should be audited regularly to ensure that the services are still alive, of course, and they are still compliant with the evolution of the rules of participation. We have documented all this in one important document, which is Deliverable 7.1, Guidelines and Recommendation for the Technical Integration of Services into the EOSC. You can find the link in this slide. But for helping user communities and service providers to better understand what is the value, what are the mechanisms, and what can be done in the EOSC landscape, we provided 3 videos. One called Join the Development of EOSC, to help people understand what is EOSC and what are its advantages. Then a second video related to the onboarding process and the quality of the resources into the EOSC recognized catalogs. And the third video explaining what are the advantages of federated AAI. These videos are available on the YouTube channel of EOSC-Pillar. They are shown in the monitor in the entrance. And then now I would like to show you one of them, which is the one related to Federated AI.
Okay. Can we get the technical team to please show the video?
This is Anne. Anne has created a service for the Earth Environment Sciences and Geosciences communities in France. Her service allows scientists to easily access different data sources, including data from satellite, in situ observations and climate models, which are usually managed and preserved separately in domain-independent repositories. Anne wants to enlarge her user base, so she wants to make her service available in the European Open Science Cloud, an initiative by the European Commission which fosters sharing of services and data among the scientific community, as well as other open science practices. Through the EOSC portal, Anne learns that EOSC offers several core services, including federated authentication and authorization infrastructures, AI. Integrating her service with Federated AI will allow her service to reach international users from different scientific communities, enabling them to use their existing federated credentials. The Indigo Identity and Access Management IAM service, one of the EOSC Federated AI solutions, features a simple design, uses open standards such as OpenID Connect, is flexible to different use cases, and auditable. Anne gets in touch with Pietro, an expert on the Indigo IAM service. With the guidelines provided by the EOSC-Pillar project and Pietro's help, Anne is able to integrate a federated AI into her service with a few clicks. In Indigo IAM, at the operational level, different roles, such as admins and standard users with different access privileges, can be defined. Now scientists from different communities and from all over the world can access Anne's service without registration. For example, Ursula, a scientist from the German research community and from another institution, can log into Anne's service. Moreover, scientists can seamlessly use different EOSC services at the same time with a single sign-on. For more information, visit eosc-pillar.eu.
So I would like to thank Trust IT for the great support for delivering these videos. So we provided other materials. There was an event organized by EOSC Future Project in collaboration with the regional projects and other entities called EOSC Provider Days in April, at the end of April this year. And during this event, I did a live demo about the service onboarding. The link is here. It starts at, it's quite long, the recording is there. It starts at minute 34, but prior to this live demo, there is an introduction, which in my opinion can be very helpful if you are interested in it. So, in addition to what I've already explained, we supported the integration of services of the applications of EOS-Pillar project with the so-called EOS core services. The main service of interest of the EOS-Pillar communities is, of course, the AAI. So there is a specific documentation about this, but also the other core services may be of interest. This means monitoring, accounting, and so on and so forth. So you will get some more information by Lisana in the last presentation of this session. And you can find all this information in deliverable 7.1. Some conclusions. So this presentation is at technical level, and what we did at technical level is to support the national actors, users, and providers to join the EOSC in different ways. So we supported the integration of the services with the core services, as I have just said. We supported the onboarding of their services into one of the EOSC recognized catalogs. We delivered a prototype for a national registry, which can be adopted by whatever institution needs to do that. And we provided the various types of materials, including the videos I've mentioned before. And during this activity, we learned some lessons. The most important one is that cooperation among different actors is paramount. So some of the activities I've described here have been brought in close cooperation with other projects. And this is not strange because the EOSC is an ecosystem where every project has to do its part. So it is important that we don't go in parallel with similar activities. So cooperation has been perceived since the beginning, and I think that some good results have been achieved. Then for catalogs, the lesson we learned is that catalogs should be sustainable. This means specifically that they should be operated by a solid institution. And if a catalog is operated by a project, the risk is that at the end of the project, all the materials, all the information in the catalog disappears. So it is important that whoever wants to operate a catalog grants a long-lasting installation of the catalog. Then the other information about catalog is that the quality of information is paramount. So the audit activities, periodic audit activity is very important. And then finally, the user-centric approach, which was my main topic in my presentation, is very important. A lot of things have already been done to address the user needs, but this, in my opinion, is not enough. Specifically, there is the need for improvement of services and tools addressing the user needs. And this, of course, has to be done at European level, but also at national level. And this is all on my side. Thank you for the attention.
Thank you, Luciano. So Luciano has been in charge of task 7.1. I forgot to mention that Geneviève was in charge of 7.4, task 7.4. And now I invite Lisana, who has been in charge and is still in charge of task 7.2 and 7.3 about the integration of services now.
Thanks, Vincent. Did you remove comments and everything? Okay. Good afternoon. So in my presentation, basically, I will just highlight the most important results out of the activities that we have been performed during the project. So here it's an outline of the three main results I would like to talk today. It's the maturity tool assessment. I will just briefly talk about it.
The second item, I would like to mention how we managed to support the use cases from Work Package 6 in order to manage them to uptake the available services and resources that were available from different partners in Pillar, but specifically for the ready-use services in our work package. And the last, I will mention the results out of the support we provided on integrating and interfacing, let's say, the different services to the federated AI, and specifically to the one instance and one of the solution made available in our project. Can I show this word? Yeah, it's okay. So the maturity tool assessment. So basically, yeah, we wanted to find a way to assess the maturity level of the different services that were available in Pillar, especially specifically for how they excel in the service delivery perspective. And once we got to know that this there was some work already available from the EOSC Nordic project, and we got to know that, yeah, they proposed this so-called maturity tool assessment, as I said, to assess the maturity level of the services from the service delivery perspective. And yeah, we decided not to start from scratch, but just use that, basically, that model and adopt it. And well, later we, let's say, advanced it by adding some other requirements we wanted that specifically data repository providers should address. Well, this is basically, well, it's a tool, but basically it's a spreadsheet in Excel, and yeah, there is a formula, like 2 formulas that score how all the service assessors, let's say, answer to the different requirements, like questions, if they address them or if they comply with them or not. And these requirements so were defined based on the FIDSM light standard for provisioning and managing IT services. And also some requirements that were provided by that time, so early during the EOSC-hub project, so-called the EOSC service description template. And well, the other features and criteria that we added for the data repositories providers. Basically, in this checklist template, there are different questions or requirements, and the service assessor should like answer for each of them if they comply with it, if they address it, like yes, either no, or not applicable if it's not applicable to to their specificity, let's say. And we added another score, actually. So there were available 2 scores, the general one, which counts on all the requirements available in this template. And we thought, why not to try to add another, let's say, score where only so-called mandatory requirements, which, we identify and classified as mandatory ones, mostly based on the existing requirements that each service provider should go through when he she wants to onboard their service. This is so more information you may find in a deliverable we published some months ago. And one, let's say, so this kind of framework, let's say, on management, on service management was, divided on 4 categories. It consists of 44 requirements, sorry, 5 categories. It consists of like 44 requirements in total. And the category are service management, which consists of 18 questions, and data repository requirements about 14 questions. Accessibility and legal requirements, 5 questions, sustainability, 1 question, and the EOSC integration possibilities, other, let's say, 5 questions. And here there is an accept list of requirements. Not sure if, sorry, you managed to see clearly. Of course, yeah, I just took only some requirements per each of the categories. An example in the service management, like, well, for the service being offered, of course, it should be available a kind of a web address where essential information about what the service is about, so a kind of service description should be available, and the URL definitely, and a contact address for the end users or for any service incidents, etc. These are, yeah, typical, let's say, questions that each service assessor should go through in order to complete and check the maturity level. We managed to have as case studies 17 services, and well, we try to classify them among these 3 categories, like thematic services and data repository management services and common services. Like there were 8 from the first group and 5 and 4 for the other 2 groups. And yeah, you have also from which country this service comes from. And here you may look at some results out of the analysis we conducted. And yeah, this shows the degree level of the service delivery, compliance. We have, like, as you may see in the legend, is in the axis you have the service name, the provider, and country code, and you have basically, yeah, the 2 different scores for each of the service that we analyzed. On average, I can say that for, well, mandatory requirements, if we calculate the averages, I think it's like more than 80%. And for the general one, like in considering all the requirements based on that checklist, is like on average like 67, if I'm not mistaken, but I have a number in another slide. And here instead, it's another way of showing this compliance degree, let's say, from each of the category that we categorized, so classified all these requirements. Like, yeah, you have so in the column you have each service name, and on the left you have the different categories, and each of this row basically, gives the scores, and you have like an icon who will help you basically to just straightforward, so come to a result if it is like a high level or moderate or just low level requirement based on the color of this anchor. And this one here basically is like just the data here with the service aggregation, the average service level compliance, just shown maybe in easy way and to read. So you have different colors and also the name of the service and the percentage on average per each service through all the different requirements categories. As you can see that each service reports a moderate or a high degree of compliance on average. And well, I skipped that part, but basically, we had like a first round, so some months ago, where we asked each service provider just to go through this checklist and try to help them what these requirements in cases where they need some explanations in order to, let's say, answer correctly all of these questions. And of course, they have another column to just comment or make like a proof that they really are addressing this requirement. And then we thought that, well, maybe as we had a little bit of time more, like what about to run again this exercise for like a second round? And well, in the second round, I would say we managed to have only 3, let's say, answers from the 3 different service providers, as you can see here, the VRE, the marketplace, which is kind of a pilot, let's say, and not yet in production, and the GPU, as a service. You have this scores from the second round, so where they went through all these requirements checklist again. And well, I think it was really good that they did, because we got to know that they did quite a lot of improvements, especially GPU as a service, fulfilled by like 100%. All the different requirements, either optional and mandatory ones. And instead for the marketplace, we were happy because they managed to improve their score as well. You can see in this different, for example, for the requirement category of accessibility and legal requirement, they did, the blue bar here, they achieved 60%. Instead, in the previous round, they were just 0%. Of course, naturally, they did some advancement and developments in order to improve their maturity level of their service. And second support, as I mentioned in my first slide, is how we managed to, let's say, properly handle or providing like means to comprehensively get all the user needs in a more formal way described, like writing requirements and respective user stories for each of the work package 6 in order so they can choose and have a request in which service they want to, or which resource they need in order to achieve their scientific goal and go on with their implementation. So here is, again, just an excerpt list of the requirements coming from the community. As I said, we were like an intermediary between all the user communities, so use cases team, and so the technical people that were providing the services based on the requests they made. And as I said, for each requirement, there is a description. There is also what kind of service or dependent resource they need. And for each of these requirements, there is also a user story associated with it. And from there, basically, the technical team of the development team from service side, they derive the different technical requirements. So how we can managed to address this need that comes from a specific use case. And here it's, yeah, a demonstration, some of the requirements mentioned, for example, for use case 6, as, yeah, you now are quite aware of what this use case is about, right? And yeah, then at the end, we managed to collect all the full, let's say, requests in accessing the available EOSC-Pillar resources and services through these metrics, as you can see. So on the column A, there are all the resources we were providing in Pillar, who is providing that, and in which category, if it's like already used, as I said, or in kind. And then if it's already in EOSC or not, the status of it, if it's in development or production. And for each use case, yeah, we have like mark and X. That use case is going to use this resource. And the last part, I will conclude with the results from the support we gave about interfacing the current services with federated AI, and specifically the instance made available, so-called Indigo IAM. And well, I will skip the part that, well, we started by a specific AI questionnaire to know about the needs, and if all the, let's say, people involved in Pillar, they know about this concept, or if they need training. And we did some as well, let's say, some calls in order to help these services that wanted to go through this interface and yeah, support them in furthering this activity. So I can say that, well, from where we started, we realized that we had already 2 services that have already interfaced their instance with one of the EOSC Federated AI, and I think it was EGI check-in solution. And then, yeah, we did the exercise, and the services that we that managed to, let's say, to integrate their service with the AI were as listed here. So there is the FGI routes, the Lanyankea Galaxy, Pico 2 is ongoing, and Software Heritage, they managed to successfully do this interface, and Materials Modeling Marketplace, and yeah, as you saw, the F2DS. And also, like from the onboarding task activity, as Luciano mentioned in his presentation, the support we provided by, yeah, so publishing and reporting these guidelines, we managed successfully to support yeah, different services, and they are listed in, yeah, in this slide here. So from current services in Pillar, there were Software Heritage Archive, Lanyankea, MMODA, Simbad, and EMM, which they come from the as a service from the open call, as I mentioned in my previous presentation, and the GPU as a service. So to conclude, so what we managed to achieve, we definitely enhanced the EOSC portfolio with these new services coming from Pillar, and we also raised the service providers awareness in advance of the EOSC validation requirements that they have to go through in order to register their resources through the checklist template, as I mentioned. And well, what we understood and let's say we recommend is that existing services should stay aligned with latest developments in the related software they are developing, and reliability and sustainability of a service offering should be transparent if they want to be demanded by many users. And once service reach the highest degree of compliance, so what is next to do? Well, we recommend that in order to enhance this delivery, they should, specifically in other European countries outside their origin country, they should start thinking of preparing the service level agreements, and if not already available, they should definitely translate the relevant documentation to English language, so it can be understandable. That's it from my side. Thank you.
No. So it's already 5, so it's the end of the session. So but I would like to thank the 3 persons. So Geneviève, Luciano and Lizana, they've done most of the work, okay, as task leaders. I would like also to thank Jos, who has been acting as deputy for WP7. He's hiding here, but he has been very instrumental. So thank you very much. Thank you all. Is there one question? Just one question. Oh, should we? One over there. Yeah, okay. We'll take it. Yeah. Yes, yes, yes.
Hi, thanks a lot for the presentations. They were really, really interesting. Just one short question to Luciano. Is there any updated list of the different EOSC catalogs available and how they're going to be, how this is going to be evolved? That's one thing. And the other thing, I've seen instructions on how to incorporate the EOSC catalog and let's say a national catalog into the EOSC, into EOSC directly, but I haven't seen so much documentation on how to enable the particular services, but this was then discussed by Lizana, definitely. So yeah.
So for the list of the EOSC recognized catalog, there is not such a list for the time being, because the onboarding agreement has been approved very recently, and the procedures to onboard catalogs into the EOSC catalog, which is the baseline for implementing the interoperability, has been defined, and we are in the process of testing this new procedure with some catalogs. The first one was the EOSC Nordic catalog. We already did this. The next one is the catalog of the DICE project. And then as soon as we have assessed our procedures against these 2 use cases, we will start onboarding other catalogs. So there are other catalogs in the queue. The NIFOS catalog is one of them, and there are others coming. So probably in the next month, some catalogs will appear with this flag as EOSC recognized catalogs. For the second question, I'm not sure I understand. May you please? Yeah. So individual. Yeah. Yeah. You can, if you think, well, if you are interested in onboarding your service into the EOSC portal catalog, you can find a lot of documentation there. If you want to onboard your service into another catalog, you have to go there to the catalog, because although interoperable catalogs are compatible, there may be a lot of differences in terms of inclusion criteria. There may be stricter inclusion criteria at specific catalogs, but the procedure may have the same effect, but may be different in the implementation. So you have to go to the appropriate catalog and find the documentation there. But if you want to have a general idea of the requirements, the documentation at the EOSC portal, in my opinion, could be helpful. If you have a specific question, you can ask me outside.
Thank you, Luciano. And finally, thanks to all the WP7 participants. And thank you all.
Thank you very much. Now, can we invite the next session to please take the stage? So, what is it? This one, right?
Yeah. Okay. Yeah. So welcome everyone to today's final session on getting a grip on sustainability, where we will present the action taken by the EOSC-Pillar to identify and define business models for open science services. So one of the critical priorities for the success of EOSC, and that is also highlighted in the multi-annual roadmap for 2023 and 2024 period, is to identify and test a number of funding models to ensure the EOSC services are viable over the long term. So we apply the business model canvas method to 12 open science IT services from the 5 pillars European countries to develop and evaluate their business model. Rebecca Reichberg, marketing manager at the Fraunhofer Institute, and Maria Cruzy, the project manager at the University of Vienna, led the task force, and they will present us with results and findings. Afterward, we will have a spectrum session moderated by Rob, where hot topics concerning the sustainability of EOSC will be presented, and we will ask our participant to take a stand and to understand better what needs an opportunity to clarify and address to ensure the sustainability of EOSC. So it's my pleasure, to give the floor to Rebecca and Marie.
Thank you very much for the introduction, Sarah. Well, Marie, what do you think? Today we saw a lot of and heard a lot of pretty interesting open science IT services.
Yes, very impressive ones. However, I'm afraid as soon as there will be no publicly funded, they will disappear.
I'm not so sure about that. Are there technical problems, maybe? Thanks a lot. Marie, do you know the Wojciech Gutenberg?
Gutenberg, this Middle Ages guy with his printing press?
Well, this project is named after him, you're right. It's a free library online with more than 60,000 ebooks, which you can download for free, and you don't even have to register yourself.
Oh, I didn't know that. Thanks, Rebecca. So, but honestly, if everything is for free, who funds the platform?
Well, take a look over there. You can see it, it's collecting donations. Therefore, it doesn't need public funding for its sustainability and to cover the costs of its operation.
Funding itself. That's what we need for our open science IT services.
I totally agree with you. And therefore, we in task 4.5 analyzed suitable business models for open science IT services. So to say, to get a grip on sustainability.
Rebecca, wait, what are you talking about? Business models? What is that?
Well, let's start with the theory. Theoretically, a business model is a blueprint on how an institution creates and captures value.
Sounds very theoretical.
Well, it's rather easy. So to say, a business model answers 4 different questions. The first question is, who is the target customer? What you may click. Who is our target customer? Who are we creating value for? Who has got problems? The second question is, what value proposition do we offer to this customer? Which means what kind of service or product are we delivering? The third question is, how do we deliver this product or service? And the fourth, but not least question is, why do we offer these services? Well, this question is pretty easy to answer in the for-profit context. Mostly it's all about, well, maximizing profits. However, in the not-for-profit context, it's hopefully mostly about creating value for society. And therefore, open science IT services in this context should focus on covering the operating costs to sustain the operation.
Ah, okay. That sounds rather easy for me. Answering 4 questions cannot be that difficult. I heard there are 55 different business model patterns. These patterns are to say specific templates like licensing or crowdsourcing. They can be linked in various ways to create a specific business model.
Exactly. That's what you can see here on the slides. By linking different business model patterns, unique business models can be developed. And if you're looking in the for-profit context, the best benchmark may be looking at Amazon, Facebook, whatsoever.
Okay, but that might work for the Silicon Valley platforms, but how can I develop a business model to make my open science IT service sustainable?
Well, by using a so-called business model canvas. You can see one over here on this slide, if Rob is clicking. It's a poster which covers different aspects of your business, and by filling out these boxes, which you can see here, you naturally answer these 4 questions required for a business model.
Last place. Sorry. Yeah, back on track. Okay, our analysis shows that services related to data as a service use pay-per-use and subscriptions.
No.
Sorry.
Thank you very much for the introduction.
I kind of have the feeling this is the wrong slide. Okay.
Doesn't matter.
Sorry for that. We trained it too many times. So, thank you very much for the introduction, Rebecca.
You're welcome, Marie. You're welcome.
Sorry. So, based on this theoretical approach, our team in task 4.5 analyzed business models for open science IT services. We selected use cases from Belgium, France, Germany, Austria, and Italy. Overall, 12 use cases were analyzed. Some of them are listed here, like the D4Science from Italy. They were either in the development or the introduction phase.
In a second step, we... Sorry. No, I forgot.
Okay.
In a second step, we conducted little workshops with an adapted version of the business model canvas. Well, it was rather workshops or interviews. Either way, we tried to answer the questions from this canvas.
And in the third step, we analyzed and compared the results to identify sustainable business models for open science IT services.
Overall, 4 different business model patterns were found: advertising, commissioning, subscriptions, and pay-per-use.
Google, for example, used personalized advertising. Apple Music applies commissioning to give musicians the possibility to offer their songs to a wide range of customers. In exchange, Apple earns a revenue.
And Amazon is a good example for combining different business model patterns. In specifically, Amazon Prime offers a lot of films for free if you pay an annual fee regularly. But if you want to watch the latest and newest films, you have got to pay per use, or so to say, pay per film in this case.
Now, our analysis shows that services related to data as a service use pay-per-use and subscriptions. However, most of their activities, about 70%, are still publicly funded.
The same applies for software as a service. All use cases we questioned used subscriptions to cover the expenses combined with public funding.
Platform as a service use advertising, commissioning, pay-per-use, and subscription to cover the operations costs of their platform.
Overall, our results show that to prevent open science IT services from being lost to the research community, different business model patterns can be used to sustain their operation.
However, open science IT services are facing various challenges regarding the sustainability of their business models.
First, when considering the target customer, it is sometimes difficult, you probably know, it is sometimes difficult to cover the requirements of all funders, as sometimes they may be ambivalent. Moreover, domain-specific open science understandings, fair data definitions, and web vocabularies may occur.
Other challenges of open IT services are related to the value proposition. First, it's difficult for most services to communicate the value of their innovations to users, science, and society. Moreover, handling such a big amount of data can be very difficult.
Considering the value creation, there's a high dependence of open science IT services on the support and the infrastructure of its home institutions. And like in most projects, there's a shortage of skilled staff and project time.
Our interviews showed that especially human resources are expensive. They make more than 70% of the costs. To cover these costs, a critical number of users is needed for every business model.
In summary, task 4.5 analyzed suitable business models for the sustainable operation of open science IT services. These results provide new empirical insights on the requirements of an open science culture in Europe.
The results indicate the following. First, business model patterns should be combined to provide open science IT services.
Second, data, software, and platform as a service models use different business model patterns to cover the operating costs.
Third, all open science IT services face different challenges regarding the sustainability of their business model. One of the most critical aspects is that all models require a certain amount to cover the operating costs.
Therefore, funding agencies should consider not only supporting the development phase of open science IT services, but also the introduction phase when there aren't already a lot of users available.
However, once the open science IT service reached the growth phase, it seems feasible to cover the costs with a combination of different business model patterns.
This brings us to the end of our presentation. Thank you very much for your attention.
And now, please welcome our business model experts to the Spectrum panel session.
No, that's all right. That was really fun. Okay, so let me just. Okay, so we're back again at the end of the day with another Spectrum panel session. But I suppose before we begin, it might be nice to first introduce the panelists that will be taking the stage. So for our panelists, may I ask you to please stand on a line for now like this. And one by one, just quickly introduce yourself so that the audience has an idea of where you're coming from when you give your perspectives. Okay, so let's start with Jos.
Jos van Bezel from KIT. I have no idea what this is going to be.
Marine Vernet from IFREMER. Here, I suppose, representing a point of view of service provider Thematic.
Okay.
Javier Quinteros, working at GAPSET in Germany and working here in Pillar in the use cases.
Geneviève Romier from CNRS.
Monika Gall from Fraunhofer IBM.
Emily Hermans from Ghent University.
Hi, I'm Marco Kuluka. I'm from the German Climate Computing Center, and I'm mainly working in use case 6 and representing the climate community.
Okay, thank you very much. So to start this, if you weren't here yesterday, so this is a Spectrum panel session. Again, reminder that there are no wrong answers, just perspectives. So to begin, let's start with everyone, please, on a line in the center. Not necessarily by height, it's just random, just stay in the middle on the neutral. Yeah, stay in follow this line. Yeah. Okay. So this is the neutral. Yeah, so this means that, okay, you're in the middle. Right. So basically, I'll mention a statement. I'll repeat it twice even. And I'll just say go, and basically you take your positions. So let's start with the first one. So funders and the broader research community need to think about the transition from project funding to sustained funding. I repeat, funders and the broader research community need to think about the transition from project funding to sustained funding. So please go, take your positions. Okay, so is there, oh, well, there can't be someone in the middle. You have to take a stand. Oh. Okay. So who would like to begin? Maybe shall we start from, okay, so you're in strongly agree.
Yes, definitely. We've seen after so many years of European projects, we've seen so many cases that actually they finish presenting a service, and in the end, when the project ends, they realize that the resources that actually they needed to run the service disappear with the project, and somehow then that's money that it was at a certain moment well invested, but somehow it's going to be useless at a certain moment. So, and that's something that needs to be thought in advance at the moment of project planning. Yeah.
Thank you. Jos, you're somewhat in the border, so I imagine you're heading more towards disagree.
Well, there's still some certainty of agreement but don't forget that we are already sustainably funding universities and research performing organizations, all this, right? So the amount of services, I'd like to know how much of these services that we are requiring and how much of this service that EOSC is supposed to bring is part of this budget that we're already spending on education and on universities and on research, right? So maybe it's possible if we from the research people are already able to fund these things ourselves. And then the question becomes, if we want to do that, why did we fail if it's only a small percentage of this amount of the budget that we already have?
Okay, thanks. So is there anyone else who would like to express an opinion on why they have chosen their current position? If none, okay, shall we proceed to the next one? Okay, please come back to the middle so that we can, we can clearly see where you are. Please do go ahead. Yes, I'm up front. Okay, the second question. So you can also see the other questions up ahead, but let's think about the next one first. There should be a European plan for the sustainability of research infrastructures rather than project-based or national funding. So let's repeat that. There should be a European plan for the sustainability of research infrastructures rather than project-based national funding. Go. Dun, 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 dun. This is a quite tough one. Well, while the others are thinking, by the way, you can also decide to change in the middle. If somehow you heard a quite convincing argument, you can actually change your decision. But I think you were quite decided from the very beginning.
Yes, because I think we need projects and we need funding for projects and national funding, because if we don't have projects, how do we invent new things? How do we develop new services? I think it's necessary.
Is there anyone who would like to express an opinion? Okay, so you have moved it a bit. Okay. Perhaps Jos, you can explain why you have decided to move a little bit closer.
Because I was, I think there is already a plan, actually. So I should be on the disagree, but I agree that there should be a plan, right? So it's both sides. And I think the plan is there, but you have to take into account, and I'm not trying to spoil the party, but the thing is that it's very complicated to get 27 member states aligned and behind something that, and in France, there may be an interest in investing in discipline A, and in the North, there may be an interest in investing in discipline B. So therefore, I think the whole range is that's a little bit disappointing, of course, but I think really that there is everything in place, but we here, this audience, projects, and I totally agree with Genevieve that you need these projects to start, but you need also projects to start living this EOSC like we're doing here. I think this is actually the plan that we're trying to perform during these projects.
Actually, I'd like to throw this question as well to the audience. Is there someone who, let's say, strongly agrees from the audience? Is everyone in disagreement? Is there anyone who would like to maybe express an opinion from the audience? I see one over there. Yes. So let me give you the mic.
I just have a question. Can you not view the governments as venture capital providing funding to the projects which are startups, and in that model sort of looking at how then from that model to sustainability, can one look at things that way?
Is your question directed in particular to one of the presenters or the panelists? Okay, to the group. Okay. Is there anyone who would like to answer that from the group on the stage or the previous presenters? Anyone? Sorry, so it seems we'll have to discuss this a little bit later during the dinner. It's quite a long one, so you'll have time to catch them. Okay, so please take the center stage again. Jos, you'll have to lie down next time if you have quite a long. Okay, so next EOSC has a clear sustainability plan for the next years. This is the statement. EOSC has a clear sustainability plan for the next years. Go. Oh, didn't even finish and everyone has their opinions. Okay, so first, tell us why.
Well, there's no sustainability plan as I know of. So I sent an email to my colleagues who are working on different EOSC projects and I didn't get any response. So I think they don't know about any sustainability plan either. And I think this will lead to, yeah, we won't be able to maintain many projects after the funding ends.
Okay. Well, maybe you should have sent an email to Monica, who seems to agree. So let's see what she thinks.
Well, at first I thought this question is not very good because we don't know about it. So the problem is, like, if we don't know about it, there's no clear plan. But then I heard this in one session yesterday that there are some plans even. I'm not quite sure, but I would look at the session slides again and then ask the right person. So people are thinking about sustainability of EOSC. I'm quite relieved. And it will go on even after EOSC-Pillar, I think, I hope.
Okay, thank you. Right, is there anyone else who would like to express an opinion about this particular statement? Yes, okay, so we have our staff member coming.
A very basic question. What do you mean by EOSC here?
Sorry, by?
EOSC.
Well, I think that's been tackled a little from the beginning, but that might be a bit out of scope for this current session. Okay, maybe we can move on to the next one. Okay, yes, please go to the center. So the next statement is, new services are essential to cope with the digital transition towards open science. New services are essential to cope with the digital transition towards open science. Okay.
Okay, and I disagree, actually. I think that the transition towards open science is more cultural thing, in fact, and it's not strictly related to services. Of course, we have researchers and IT crew that builds these services, but before building these services, it should be already in the community, this idea and the feeling of what is open science and what does it actually imply. And then only after that, this will appear in the new services.
Thank you. Maybe we can continue with this side as well. So Emily, tell me about what you think and why you're somewhat between disagree or strongly.
Yeah, I agree with Xavier here, but I would also like to add that if we look at the services that already exist, there is already a lot out there. And I think in terms of sustainability, it's important to sustain the services we already have. And also to connect those services and put our efforts there. Of course, it's important to keep innovating and to move things forward. But I would suggest that really to make the transformation towards open science, the services are already there. It's a bit like the climate change discussion, I would say. Like, once we have the technology, then we'll start saving the climate or something like that. I think everything is in place to have an open science research environment. And of course, new services can add to that. But yeah, I don't think it's like the top priority now.
Okay, good. Marine, from your side, what is your opinion on this? And I see that you agree.
Yes, maybe because I took the question on another point of view, but I think that there are a lot of discipline-related services existing, but that we need some more high-level integrated services on top of them in order to go towards a more digital transition towards open science. So that's why I agree. And there are obviously a lot of reflection and demonstrating services and development ongoing, but they don't really exist as operational right now. So that's why I'm here.
Anyone else who would like to offer up another opinion that hasn't been expressed yet from the group, or perhaps from the audience? Is there somebody who would like to say something? Okay, if none, then we can proceed to the next one. Please take your places in the center. And the next question, or rather statement, is the research community needs to address the transition from project funding to sustainable funding. The research community needs to address the transition from project funding to sustainable funding. Please take your positions. Okay. Yes, okay. So first, Emily.
Yeah, I'm really curious because maybe I don't read it right, but I think the research community is not the right target audience to address here. I think they can contribute to sustainability, but more in terms of making their data fair or using the services available. But I don't see them having the leverage to really make funding more sustainable, or I'm maybe missing something, but I'm curious to hear what the other side is saying.
Okay.
Yeah, I understood the question a bit differently. So the question is, do we need project funding or sustainable funding? And well, on the one hand, project funding can be great for more risky things to kickstart new tools, which can be later taken over into the operational work. But then on the other hand, many projects are being abandoned after the work, which is a pity because we invested lots of money. So I agree that we need to shift towards more sustainable funding additionally to project funding.
Next, Javier.
Thanks. Well, probably a question to all the audience that could give an example of what my opinion is. We all have read and written many projects and proposals, and actually we need to put there the cost of the services in every single proposal. And when we do that, the cost for the services is for the 3 years that the project lasts. And usually that's a value that it's not really small. It's pretty high usually, and it's surprisingly high sometimes. So what I've never seen in a project, or at least only a few times, someone that declares the cost will be covered for the next 10 years or the 20 years will be secured by my institution, the other institution, or how is it going to be covered? And there is this concept of free services actually doesn't exist. Someone is paying for that. The question is, who is paying for that? And well, we have services that are working continuously, but it should be clear, even in the project, that services working at will be continuously working because someone is securing the funding.
Thank you. Is there anyone else from the group who would like to offer up an opinion? Yes. Give.
I would like to add a comment. What is a research community? It has to be an entity, a legal entity, or at least a formal entity to be able to have sustainable funding. So let's organize the research communities first, and after we will convince them to have a sustainable funding. But for the moment, it's difficult.
Any other thoughts from the panel?
Yeah, so next time I'm requested to update the data management plan. My last sentence will be, I will not be able to keep the data because I do not have money to store it for the long term. And let's see what happens there. But I don't think anything will happen. But actually, this data management plan was a start for long-term preservation, right? And I'm not sure if we managed to do that. And we all have the tools already.
Further comments? Okay, if none. Oh, yes, from the front, our staff is coming.
Yes, so it's a bit tricky and I understand. So the research community, I mean, we do have like researchers working on applied sciences and researchers working on fundamental sciences. How is fundamental science going to be sustainable funded?
Is there someone who would like to mention something?
That's really difficult for me to understand.
I think it's a clarification on the question, yes, or rather on the statement.
No, I mean, it's not clear. I mean, we say research community. I mean, research community consists of, I mean, obviously research that can be sustainable and research that it's really hard to be sustainable. I mean, in the sense that they cannot, gain money. I mean, like fundamental sciences. I don't know, like theoretical physics, I mean, mathematics and these kind of sciences. How is it going to be sustainable?
Perhaps there's someone who can provide more insight into the wording of the question from the presenters. If you'd like to.
Well, honestly, these statements were made to start such a controversial discussion. So it's good that you are asking this question, and I think we should discuss this at dinner, but there's no right or wrong with this statement. Does the research community need sustainable funding, or can it just be publicly funded? Is it the solution? We all don't know, but I think we have to discuss it, maybe at dinner.
Excellent. Okay. Is there any other statements or questions? Yes, we have one over there towards the middle. Yes.
Yeah, so I mean, actually, it's more of a remark based on the previous question, because I found it very interesting, because that's some question that I have also asked myself, but from a different point of view, actually from the software point of view, because I'm mainly develop software solutions, but it suffers from the same kind of problem that the ground science actually. So there are a lot of bits, let's say, like in the case of software, they are mainly libraries that are most of the time open source and everybody's using, or things like CCAN that we are using for the catalogs and such. And sometimes they are well funded because institutions somehow flow money into them, but some other times everybody's relying on them and they are, let's say, not even getting enough funding to be maintained. So, I just wanted to highlight that this same problem that happens to ground science, let's say, also applies to the most basic building blocks of software. So, but yeah, it's really an interesting question, because those things don't have actual visibility. Only, let's say, the end product or the applied science have visibility, but not really the building blocks. Therefore, it's difficult to get funding, I believe.
Okay, I think with that we have reached our time limit. But anyways, first let's give our panelists a round of applause for doing such a good sport. Thank you. And now I pass the floor to the session organizers in case you want to say some last few words.
Yes. Thank you all.
Thank you all. And yes, as a conclusion, what to say, there is still a need to accommodate a range of funding models in use by service provider who want to federate their service in EOSC. Such funding models could include subscription, or, as Rebecca showed, also other pay-per-use models, as well as services that are made freely available, of course. In addition, it should be possible to enable public-funded research infrastructures and infrastructure such as data repositories and also computational resources to be used in a cross-border context, with the possibility of recovering the costs. So there is still a work to do in this area, and in order to clarify the value proposition for any service provider to federate the EOSC, we propose this method, the business model canvas. And so, yes, we have tried to provide our contribution to this discussion, and I hope that the study that we have provided will be helpful in focusing, especially in this method that we have adopted, that could be applied also to other service providers. So I would like to thank all our speakers and the participants in the Spectrum session for their contribution, which will be collected and hopefully also presented in the final study. And so thank you all for your participation. And if you want to keep on discuss, yeah, let's go to have a walk to the dinner, and let's continue like this. So thank you very much.
Right, so that ends day 2, and it has given us a lot of food for thought for the dinner. And as I mentioned earlier, you're all welcome to join us. Let me just show you exactly where we will be. So, oh, just. Okay, so duplicate my screen. So the restaurant where we will be is called Bowfinger. It's within the city. It's near the Bastille Plaza, and it's some few minutes from here by metro, or you can also walk, but it will take longer, of course. And our dinner is at 7:30. So this is a traditional French restaurant. If I'm not mistaken, it's Alsatian cuisine. So you're all very much welcome to join us. So we'll see you there. Yeah, so see you as well tomorrow. So bye. Thank you.